Hello, Globebusters. Yes, of course they're serious. You do? You have? No kidding. Uh-huh. Oh, they'll cure your globitis this week. Thank you. We got one!
Ladies and gentlemen,
It's the Globebusters.
What are you supposed to be, some kind of a cosmonaut?
No, we're exterminators.
and now, here's your host.
And welcome everybody to Globebusters, Reinterpreting Our World. I'm your host, Bob Xanadude60, and here we are, 7 years later. Unfreaking believable. I can't believe we've been doing this for 7 years. It's just gone by so fast, and it's just really amazing. And especially the past couple of years have gone by incredibly fast also, but here we are back for our 7th season, and hopefully we're going to make this a good one for you guys. We've got a few changes that we've made, and I took some suggestions from you guys as far as what you would like to see and hear us cover. But one of the main things that I want to cover today, and this was kind of in keeping with a promise that I made last season, when I was telling you about I think it's time that we put together a model. I'm not really interested in what the Globers think, or trying to debunk our flat Earth models with their globe Earth theory and their globe Earth physics, because the reality is they don't even have a map, right? They have no map. They have no map at all. If you want to call the Mercator a realistic map of the Earth, well, then you are smoking crack. And it's not, and there is not one, or they wouldn't have so many different types of projections of maps. So they cannot explain anything. They don't have a model for anything. Even their model for gravity is nothing like what we've come up with. And they got nothing. I've said that for years and years and years. And I think it's time that we press forward. And like I said, I just don't care what the Globers think at all. And, Globers, if you're going to, come in and comment and sit there and say, oh, you can't do that because the globe works this way. And it's like, well, this isn't a globe. So don't even try. If you're interested in how we're going to present this model, then that'll be pretty cool. I want all the thinking heads we can get on this, although I don't really expect you guys to be a lot of help, but I think that the Flat Earth community has had this well in hand for quite some time. And what I'm going to show you today, guys, I think is nothing new, but I'm going to present it in a little bit different way so that we can get our point across as to how we are, doing this model. And instead of trying to describe a Flat Earth model for you, what we're going to do is we're going to tell you what we already have, what we know for a fact we already have, even that is acknowledged by mainstream physics. And then we're going to show you where mainstream physics kind of uses and then doesn't use their own model and their own truths at their convenience when it is ultimately a detriment to their overall model, and it debunks the globe over and over and over again. So I think this is going to be kind of interesting to do this. This is definitely a new territory for us, and I'm kind of looking forward to it. So also today we will be covering a couple new NASA items, which are kind of pretty funny. Zack Zabala is going to have a couple things that he's going to present to us. Well, actually, he's got a new video out and a new experiment out that I think is definitely worthwhile, and we'll be letting him talk about that. But so before we get to that, let's go ahead and introduce the panel. First up, as always, would be Jeran from Jeranism. How you doing, Jeran? You're muted, Jeran.
There we go. Didn't it used to be on the bottom of the actual main screen? Now it's on a little box on the side. I don't know. Skype is always changing. Doing fantastic, Bob. Happy to be here.
Yeah, they do. They change it all the time. So, and I'm still not sure exactly what software I'm going to settle on. I kind of want to go back to the one I was using before, but I'm not sure. Yeah, StreamYard. The only thing I don't like about StreamYard is the audio quality is not that good for music. So.
Yeah, I'm a big OBS fan still. I think that you can do so much with it that I don't even know about yet. But I don't know if my video editing, I've moved over to DaVinci. I have to ask Drew if he's looked at that at all. It is unbelievable, but you need a really good computer or else it won't work. But I'm like in bliss with this new video editor. So very exciting.
Oh, that's nice. Well, you do have a nice computer and everything. And by the way, you did get it fixed, and it just, you needed to just wipe it so the boot sector was corrupted. Is that what was wrong with it?
Yeah, they couldn't. They just said, just reinstall Windows, and then they said, "You have everything backed up, right?" I'm like, "Yeah, I think so." For the most part, I have most of the stuff on the backup hard drives. But what I didn't have backed up is all. You have to download all the folders, all the programs again. Pain in the butt to go set all the settings and then I realized I never exported my scenes from OBS, so that's the nightmare.
That's a nightmare, a complete nightmare.
Mm-hmm. So, and the reason I didn't do it, I did it on the other computer, but I never did it on this one because it was like, it's too new of a computer. I didn't think there was a possibility of that kind of catastrophe happening to where I lost everything. So I'm able to go, but I've changed so much since I used to be on the other. It's just a nightmare. So I'm having to redo all the scenes and set that all up again from scratch, which is no fun. So I did tell Dave Weiss about it. I said, Dave, do this right now. So he went and did it and backed up his stuff because he does all his presentations all through OBS now.
Oh, okay.
So
there you have it.
He's got his stuff backed up. So if you have an OBS, back your stuff up in case it goes down.
Yeah, I should probably. Well, I don't have it nearly as complex as you do. I keep it as simple as possible because I'm getting too old to learn all this new shit. So
yeah.
So I just follow the KISS method, keep it simple, stupid, and there we go.
There you go.
Excellent. Okay, so next up we have from somewhere in the United States. I don't even know where he is. Mr. Austin Whitsitt from Whitsitt Gets It. How you doing, Austin?
Good. So it's actually kind of chilly here, believe it or not, but I'm doing good. Glad to be back with the fam.
Okay, and where are you again? Because you cut out during that part.
We are in like north central Florida, near Wekiva Springs.
Oh, okay. I have no idea where Wekiva Springs is, but sounds good. Is it warm there? Because it's cold as hell here.
Yeah, I mean, it's cold for here. Like it's actually been kind of chilly. I'm wearing a jacket, but yeah, I mean, it's not as cold as anywhere north of here, of course.
Okay, cool. Well, I'm glad you are back online, and I assume you guys are still working on the theme song. Have you made any progress on it at all?
Yes. We just want to make sure it's good, and we have some. I don't really want to give too much of the ideas away, but yeah, we're in progress.
Okay, cool. Well, we're looking forward to it with bated breath and everything. But yeah, Austin and Kai are going to be doing our new Glowbusters theme song because they did such a good job with Austin's. I thought that'd be really cool if they could do one for Glowbusters. So they are busily working on that, and maybe next week, if we're lucky, or the week after, whatever, we'll get to hear that pretty soon. So that would be awesome. All right, and next up from somewhere in Switzerland, I think, is Iro Landucci from Nur Para Todos. How you doing, Iro?
Very, very good. Yeah, I'm in the Jesuit church right now.
Oh.
I became because so many times without Glowbuster I became a friend of the lead, and now I am dressing like a Templar. I have my sword right here.
The apron for the Freemasonry apron.
Of course, like you, Jeran.
Yeah,
Come on, get out of the closet.
that's all I'm wearing. That's all I'm wearing. Just so you know that.
Of course, man. Of course. And in fact, I think that the next Sunday we need to activate our webcams and dress and show the people who are really are. Okay?
We need to do that. Oh, they don't want
Hello.
to burn.
No, that's for sure. Hello, everyone, and it's really nice to get back to work.
Yeah, absolutely. Yeah, it's just kind of weird. We took off. Well, I took off the entire month, about 6 weeks. So, but it feels good to actually do that because, it was getting so weird with all the stupid, videos that were coming out and infighting and craziness. And I'm sure there will be more. But honestly, Jeran and I talked about this, and we're just going to ignore it, because, honestly, people that make those kind of videos that call everybody shills are just screaming for attention, and we don't need to give it to them. And it's hard not to, guys. I mean, it's not like it's just, oh yeah, I'm going to take it and let them keep doing it. But sometimes,
well, to be honest, we wouldn't even know those things were happening if it wasn't for the people who watch us bringing it to our attention.
That's true.
That was the problem I had with it, is that a lot of people were telling me, oh, you should have ignored it. I'm like, but you guys were all the ones coming saying, well, what about this? What about that? He said this. Is that true? So, I mean, it's like, do you want me to answer accusations or just move forward? And I've come to the conclusion that I'm going to move forward. Doesn't matter. Anybody who wants to think those things about me after 7 years has a absolute marble loose, and I can't wait around for them.
Yeah, absolutely. It's just not worth it. And we have better things to do, honestly. And these people, when their content gets so bad that they can't figure out anything else to make, or their life becomes a sewer, and they just aren't able to do anything, well, then the next thing they do, for a quick pick me up on the channel watches and stuff, is to attack somebody else, call them shills, make up all kinds of stuff like that. And unfortunately, some are actually really good at it, and it's unfortunate, but I was at least I liked some of the community's reaction. A lot of the community's reaction to some of these attacks were like, all you're doing is causing division. And yeah, we do say that a lot because that's exactly what they're doing. I don't want to cause division. I mean, we all have people that we like. We all have people we don't like. And, so be it. But everybody's free to do their own thing. So, that's what we're going to do. And we're just going to, keep hitting it forward and do our thing.
Collecting those shield checks.
Yeah, like no shield checks. All right. So next up, we have Mr. Zachary Zabala, or Good Times for All, if you prefer. How you doing, Zach?
Hey, Bob. Doing great. Hey, everybody. Yeah, just really excited that Globebusters is back. Sunday is going to be normal again.
Yeah, no kidding.
It's been 7 years to be doing this every Sunday. There was a rule when I was in Indiana at the house. Don't bother me between 2 and 5 on Sunday p.m. That's my church. So yeah, this is awesome.
Yeah, I know. God, like I said, it's still hard to believe that we've been around that long. So, but that's cool. And we just recently passed our 66,666 subs. We passed that about a week ago. We're at a little over 67,000 subs now. So, but God, I watched and watched and watched. I really wanted to get a screenshot of it. I'm changing to 66666, but unfortunately it jumped over by 2 just out of the blue. So, oh well. I can't, put that bait out there for people to come and tease us with it, right? So, okay. All right. So, Zach, I guess what I want to start with is on you. You came up with something that we covered on a Wednesday night, a little bit, and it was basically an idea about the sun and the sun wagon wheeling, right? Or the moon wagon, sun wagon wheeling, right? And you kind of came up with an experiment, right? Both of them, that you think is going to work out really well. And it just so happens that we've got people at the right latitudes that can check this within about 2 weeks from today. And did you want to go and explain that a little bit before we start the video? I'm going to show that video to everybody. the one you released on it. But before that, you want to give it a little bit of an intro?
Yeah, this is actually something I learned a few years ago, and I threw this question out, but I never really pursued it too much. It's my fault, but I should have. Now that I'm thinking back, I should have really modeled it and tested it like I've done now. But it's as we watch the moon and sun wagon wheel across the sky, Nick Phuket Word, he did a great video showing that if you take a flat disk, because we only see half of the sun or the moon, ever. But if you take that flat disk and move it in a circle over your head, that we get the exact same appearance that we do down here on the ground when we look at these luminaries up in the sky. So it's almost as if they're like flat disks and you can put two dots on a flat disk and maybe stick it out on a ceiling fan. And if you stand in the middle and rotate it, those dots aren't going to rotate at all. They're going to always stay in the same spot because you're at the center of their rotation. But if you move away from the center or change your latitude, that rotation amount changes. And it changes drastically from the inside of the arc to the outside of the arc. So on a globe, 45 degrees north and 45 degrees south should see the exact same rotation when the luminary is passing over the equator. We should get the exact same amount of rotation, but on the flat Earth model, it is drastically different. So This is something anybody can do with a camera. And yeah, I think this is a nail in the coffin. I'm hoping people will take this and run with it and we get data from all over.
Yeah, that would be awesome. And the date coming up for that is what, about 2 weeks, you said?
Yeah, February 5th will be the next time the moon is passing over the equator. And then February 20th after that. It happens right about every 2 weeks because the moon passes like Cancer back to Cancer every month.
Right.
So every 2 weeks.
So basically, the ideal latitudes then for people, if they're on it, is going to be 45 north or 45 south. But there is a range of latitudes that work better. And as I understand it, this isn't necessarily a flat Earth proof, but it is a globe killer. Because,
globe killer.
Yeah, definitely globe killer. And I think I understand that this is my area where I have a little bit of trouble with. But so if we have anybody specifically in the south, when you're getting down to 45 south, you're getting pretty far south down there. But and I'm not even sure what is 45 south. Is that Ushuaia territory or where is that?
Yeah, I think that's down there in Argentina. Maybe South of Africa reaches that far, but I know Australia doesn't because Lucas is at 37 and he's pretty close to the southern border of Australia.
Yeah. So Iru, what's your latitude in Argentina?
I never checked that. Really.
Really?
No. Yeah. I never, because I am not a guy of maps and numbers and equation, things like that. I am more of the visuals and observation, things like that. So I never did any sun experiments or measurements of stars and things like that. So I never check my latitude.
Huh, okay.
But I can do it right now.
It goes all the way, 38 south Argentina. I'm not sure if that's northern Argentina or southern Argentina. So yeah, I don't think there's much that's at 45 degrees.
We are very far away from from the coast of Antarctica. Of course, we are not near to 60 degrees latitude and things like that. So that for sure.
Right. So basically, Zach, you have a range of latitudes that will work. What would that be?
Yeah, we're looking for something at least 30 degrees north and 30 degrees south. Once you get to about 15 degrees, the north and south, there's still a difference, but it's a lot closer and doesn't leave room for error, while you're getting your data. But at 30 degrees, it's drastically different. I mean, completely different.
Yeah. So you're going to have...
I'll show you videos how I measured all that stuff out and got these angles.
Okay. And so you're going to have Lucas, LC King, do the measurements in Australia, and I'm not exactly sure what latitude he's at. But again, like I
30
said, 30 something.
37 south, and I'll be at 35 north.
Okay.
Yeah, Argentina is 30 between 34 and 38.
Okay. So basically, if the Earth is an oblate spheroid, then in theory, the latitudes, we need to fairly much match the latitudes, so that they are on the same part of the supposed curvature, right, of the Earth, for comparison.
Yes,
Okay, so let's go ahead and play this video and kind of get an explanation to the concept of this to everybody. And, like I said, get in touch with Zack. His emails in the show notes and everything, or me, whatever. And we will, get you set up with what you need to measure and when. And, the more results we have coming in, obviously, the better. But, and then the rest of you guys, just take a look at this and see if you think that this will work the way that we think it does. And it seems to make sense to me. Makes sense to Cami. It makes sense to Zack. So I trust them with that because I'm not so good at it, but it does make sense to me. So I think that it is probably a very viable test. So let's go ahead and give it a watch. Here we go. And I'm going to speed this up just a little bit so we're not going so slow.
Hello, everybody out there in YouTube land. This is a good times for all. There's Zachary Zabal here if you prefer. This video is going to kind of be a blast from the past, the way I used to do videos with, just me and a cell phone, because I'm going to expand upon this one and just don't have the data yet to make a video. I don't know yet, really, to be true. But here we have our flat Earth model. We have the North Pole in the center. We have our 45-degree north mark at the blue circle, the equator at the red, and our 45-degree south here with the green. Now what I did, we have these two pieces of paper, okay? Now they have a line running right down the center of them that are exactly the same, and then lines running a T right through here. I know this one just looks like a few different lines marked all over each other, and I'll show you why. But the T is equal on both of them. Now, this has to do with the rotation that we see with the sun and moon wagon wheeling in the sky. As you watch it throughout the day, you'll notice that the sun and moon kind of do a rotation. They turn this way in the sky as you watch them. And my last video I did showed how that works on a flat Earth with the perspective. And it got me thinking, can we tell a difference between the perspective from 45 degrees north and 45 degrees south on a flat plane? And will it be different than the globe? See, in a globe, the perspective at 45 degree north and 45 degree south would be the same as long as the luminary was passing over the equator at that time. So what I did is we have some holes punched in here that go in the hole in the center. And is that it? Oh, hold on a sec. Got to make sure you get it in the hole. Oh, I'm having trouble. Let me, I'm going to have to push down on this a little bit. There we go. Give it a groove. The paper must have moved on top. But as you can see here now, that line that goes this way on the piece of paper, it follows the equator perfectly. So it's going to go all the way around and be lined up with the equator. And what these are is we have a line every 15 degrees. The luminaries in the sky move about 15 degrees every hour. So this would be our solar noon right here. All of our measurements will be taken from this 0 degrees right here. And this is the latitude or the longitude that you are on. So whatever longitude you're on, whether it be north or south of the equator, you're always on that same longitude line. So this will be your longitude line. No matter where you are, we're going to mark that as 0. So if you go 3 hours before solar noon, and we line that up over here, that would be at our 45 degree mark. We line up our sun where it is, and then we take a shot from the from the 45 degree mark right here. And you can see that it lines up with that line that's already on there. We move it down here to 3 hours past. We get our sun in the right spot, and you can see that it lines up with this other line. So that's the amount of rotation we see from 45 degrees north. I've measured these. It's about 58 degrees. If you set this on here, put that there, it almost comes out to be 60 degrees, but it's about 58, I would say, something like that. So our next one will be taken from out here at 45 degrees south on our longitude line. Now, it can be taken at any latitude line. It doesn't have to be 45 degrees north or 45 degrees south. Now, as you can see, the lines are kind of all garbled up right here, and I'll show you why in a second. But again, we follow right along that equator with our middle line. Now, when we go to 45 degrees or 3 hours before solar noon, and we set this way out here, it barely crosses over that line. You know, there's just a little cross right there. We move it down here, 3 hours past, line this up, no comparison. See how why this X right here is so squinched together compared to this one? Now on a globe model, these two should look the exact same. So, are the sun and moon that we've been looking at, you know, we see them almost every day, do they disprove the globe themselves? You know, just from measurements from different spots along the plane. Now, before we get into the parameters you need to use to take your shots, I'm just going to throw this out there first. If you'd like to help, I have some measurements already from the north. I know other people that have them as well, but we really need some data collected from out here. Anywhere, you know, close to, I'd say at least 30 degrees south or more. We want to try and get some accurate data gathered from there of just that wagon wheel rotation that we appear to see in the sky. Again, if you don't know what I'm talking about, how the sun and moon wagon wheel, the description will be in the video below. And yeah, just throwing this out here, I think this could be a globe killer, folks. Undisputable, depending on what the data shows. If it does show they're the same, not going back to a globe, of course, there's way too many proofs. So it's really just going to teach us something about the sun and moon and the appearance from the difference from north to south. Is there more going on up in the sky than we, you know? I mean, the sky is such a mystery already. This could just be another big, you know, another big conundrum we're going to have to try and figure out. So yeah, all we can do is learn from trying this, but I'm going to need some help from out here. So that's it. Let me know what you guys think in the comments. I think this could be a good one. This is Good Times for All here, signing out, as always.
All right. So there we have it. So what do you guys think? Jeran, what do you think about that? You think that's viable? It kind of reminds me of Corey Fell's experiments. Yeah, doesn't it?
Yeah, it does. No, I think it's a good idea. Anything that we can do, and I think bringing the community together. I wanted to bring up that there was a guy who reached out to me. He's willing to fund it. I don't know if he meant completely, but a lot of it, I think. He was just asking me, couldn't we do the 3 balloon idea and try and get the sun in the middle? And I think it's something we should look at come a little better weather here, because if we wait till like June, if you kind of can imagine waiting until noon for like Texas, and then if we launched a balloon from the East Coast and one from the West Coast, and we do it synchronized, so we're all doing it at the same time, and then we also launch a balloon from somewhere south like Mexico or even further south. Because if you kind of think of all the videos you've seen of high altitude flights, they all are not high altitude flights, high altitude balloons. If you kind of picture where the sun always is, the sun's always off to the side, right? The balloon's swinging around and there's just the sun out there in the distance. Well, if we wait till noon for Texas and we launch East Coast, West Coast, and south of the sun, then it couldn't be that all 3 balloons see that view. If it does, it proves the sun is close. How could you have a sun 93 million miles up, kind of picture a globe and then it's up, but yet each of the balloons is barely off the ball and sideways they can all see the sun? Does that make sense what I'm saying?
Yeah, absolutely. I totally get that.
So, they asked me how much did I think it would cost, and I said, probably, 6,000 or so, maybe plus a little bit. What was it last time? About 2,200 a balloon?
Yeah, and we had them fairly well decked out with cameras, but you really do need all those views, And in fact, the more views, the better. I'd like to get, more stuff looking up just to see if we can catch any signs of the firmament.
Yeah, so something we could look at, because that might be a fun little project, and then we'll just have to figure out where's south and do that by the June solstice. So, no, but I think Zach's idea sounds great, and it's gets people out there and working on things. So, yeah.
Cool. All right. Well, there you go, Zach. So if you guys want to help out on that, by all means, get in touch with us. And if you're down in that neck of the woods, that would be super. You don't know how many viewers we get. We do have some viewers in South Africa and stuff. So, anywhere from over there would work great also, as long as you're in that zone. But I think 45 would be ideal, because that would pretty much give you the maximum deviation, I think, for each latitude above and below the equator. So there you have it. Oops.
Well, thank you for sharing that.
No worries. All right. So other things in news, I'm going to actually, I think what I want to do is I think I'm going to cover the kind of the main presentation first, so that we get the YouTube viewers in on this. I was going to do it secondly, but I think this is definitely something that is not something YouTube would censor. So I think I'm just going to go through this and point out a few things as to where we are going to start with our model. Okay. And so you guys have been watching, this presentation here. We watched it a couple times already, where this is one of the effects that, Jeran and I have talked about, where you can produce certain light effects, and what we'd assume would be a firmament or a dome, and get different sun positions that actually make light patterns that do seem to match very closely the sun distribution pattern that lays down on the flat Earth map below it. Okay, so that's just something to keep in mind when that's done. So it also has that, and this one covers the coffee cup caustic as well. So if you guys remember that, this is how we get our 24-hour Antarctic sunshine. And it's going to work into this model ultimately very, very well. But all right, so let's get back to where we want to go with this. I was going to play these first, but let's go to this. Hang on just a second, guys. All right, so the way I want to start this out, guys, is you've heard me talk about the model of the flat Earth and how I believe, that we have our firmament, that we are within a charged box that has the firmament over the top. Obviously, we're covered on the sides. We would have to be in order to have pressurized air pressure. That is the necessary antecedent for having air pressure is, you have to have a container, right? Everybody knows that. So, but what I'm going to show you is how the mainstream science looks at our world and how they interpret it. And this is actually really, really interesting. But before we do that, I want you to learn about a little electronic component that's called a capacitor and what it does. And the reason that I'm focusing in on this capacitor is because this is one of the base elements into how this entire model functions. And ironically, you will hear mainstream acknowledge this 100% all the time. But then, of course, they come up with other stuff that completely denies it. And then they say, no, except for that's, anyway, they wind up sticking their foot in their mouth over and over and over again. But let's get a sense of what's going on in our Earth now. So if you can imagine in your mind, first thing, that if we are on a flat Earth, that you can, look at it as like the dinner plate or a Frisbee, whatever. So you have basically a kind of a slightly elongated elliptical circle on the ground. And then above that, you would have, let's say, some crystalline or metal type of roof over it, right? And I believe this roof is at about 62 miles or 100 kilometers. So, and then of course down that, and within there, you're also going to have another chamber, as the firmament is described, where the sun and the stars actually reside, right? So the first thing I want you to understand is how a capacitor works and what it does, and how this kind of gives us our model for what we're going to present today. So let's watch this. And this only takes a couple minutes, and we are off. Oops.
A capacitor is similar to a battery in that both store electrical energy, but a capacitor is a much simpler device that can't produce new electrons. It only stores them. However, capacitors can do things a battery can't, as we will show here. For the purposes of this animation, we'll focus on different parts of the current propagating through the wires at different times. When we close the switch, electricity immediately runs throughout the circuit. Although the convention is to think of electrical current as moving from positive to negative, electrons actually move from negative to positive, as we represent here with yellow particles. As you can see, the battery is not much good at powering this motor to lift this weight, because it discharges gradually, much more slowly than would a capacitor with the same charge. Here we'll learn why a capacitor is much better suited to such a task than a battery. Like a battery, a capacitor has two terminals, positive and negative. Inside the capacitor, the terminals connect to two metal plates separated by an insulator that keeps the plates from touching each other and allows them to hold opposite charges, maintaining an electric field. Capacitors can be useful for storing and quickly discharging electricity, so you can power, for example, an electric motor, as we'll show here. First, we need to charge a capacitor. By closing the switch, we create a circuit that includes both the capacitor and the battery. Electrons flow from the battery to the capacitor, where they are stored. Here, a yellow glow represents the increasing charge held by the plate.
Okay, and one thing I want you to notice here is you notice inside of the capacitor, there are essentially two plates, right? You have a plate here and a plate here. One is charged positive, one is charged negative. And when the surface area of these plates get charged up with electrons or protons or however you want to look at it, and I'm not advocating for any particulate matter anyway, all I'm saying is that there is a charge that is present there. This much is irrefutable, okay? Now, how that comes about, however you want to explain that, that's up to you. But we'll just try and keep it simple here. But what's happening is we have one plate that's positive, one plate that's negative. And so the battery is basically sending the supply of electrons and supply of protons, or shortage of electrons to the other, to create a charge differential between the two plates. And when that happens, when you have positive on one side and negative on the other, well, what happens? It's the same thing that happens with everything else, like a magnet. They attract each other, right? So that's why this is the base element of what we're talking about. And of course, you can already begin to imagine that where I'm going to take this next is I'm going to flip this up, where this plate here, I'm going to flip it up 90 degrees, and where this becomes the top plate or the firmament, and I'm going to flip, and that'll bring this down to here, and that will make it the Earth, okay? And we call these Gaussian surfaces, but we'll get to that in just a minute. Let's continue.
For every electron gained by that negative plate, an electron is lost by the positive plate, maintaining the capacitor in equilibrium. Here, the red glow represents the positive charge held by the plate that increases with each parting electron. The capacitor continues to charge until it attains the voltage of the battery charging it. Now that the capacitor is fully charged, let's put all that stored energy to use. By connecting it to a new circuit, we can power a small motor. This electrical current powers the pulley to lift the weight until the charge dissipates. The electrons on the capacitor's negative terminal are drawn to its positive terminal. They rush along the path that leads there, straight through the motor. Let's watch this again. Even though the battery and the capacitor attempted this task with the same amount of charge, only the capacitor successfully powers the motor lifting the weight, because it discharges much more quickly. This feature makes capacitors useful for powering things that need a quick surge of energy, such as flash bulbs and cameras, and starter motors and audio amplifiers in your car.
All right, so there we have it. Basically, that's pretty simple how that works. And one of the advantages, of course, to this is, unlike the battery, which can only deliver so much current at a time, the capacitor can deliver a much faster stream of current than the battery can. And that, like you said, it makes it good for starter motors. It seemed like that. So, okay, so that's basically the function of a capacitor. Now, something else a capacitor does is it can act as kind of a buffer, right? It can act as if the source power maybe falters a little bit, it can also stabilize that by supplementing the source power with some discharge off the capacitor. So in other words, it makes it a fairly nice, stable, equal flow of electricity. Okay. Now, so
just about circuit board uses this as well. I mean,
oh God, yes.
Of all the stuff I've taken apart, I've never seen one that didn't have capacitors on it. Like you said, to steady that flow and take electricity, keep it nice and even. Yeah, you won't find one. They're used everywhere.
Yeah, you won't. Capacitors are used for coupling. They're used for filtering. They are used for so many purposes in electronics. And it's a very, very simple concept too. That's the great thing about it. It's just these two basic plates. Now, there's obviously several different kinds, but this is the capacitor in its base element. So you have to ask yourself, what are these charged particles? Where do they come from? And the answer to that is they are using pre-existing matter that is already inside of the plates, because the charge in and of itself that's coming out of the battery that is charging other particulate matter is charging stuff like the molecules of gases in air, okay, or something like that. In other words, there has to be some sort of particulate matter present for these capacitors to work, right? They won't work ultimately in a high vacuum condition. Because why? Because there is no particulate matter, and then we've already covered the vacuum, and how that works. If you don't have any particulates in there, and it takes a lot more and more and more and more power to get these particulates out of there. Well, if you don't have anything in there to charge in the first place, well, then you cannot have any electrostatic energy. And this is something that the mainstream kind of flops back and forth on, and we're going to cover that here in just a minute. But what's interesting about it is that idea not only destroys, once again, their model, but it also props up the flat Earth model. So how does it do that? All right, so let's move on to, let me close this one. And where is it? I'm sorry, I don't have these in order, guys. Okay, so you guys have seen me use this particular video before. I've talked about electrostatic gravity, the electricity in the atmosphere, and basically, what it is it's charging up the air or gases, whatever, in the atmosphere. And then you can literally manipulate these air or gas molecules and do, whatever you want to with them statically. So if you remember this, this is a video on collecting static electricity out of the air. So what I want you to see here is, first of all, that this particular section was written by Richard Feynman. Of course, is a very much acknowledged mainstream physicist, even though he's kind of a nutcase sometimes. He's very much acknowledged in the mainstream physics world, so that's why we're going to quote his work. I also have his book in here that describes very, very much how this works. So I'm going to play this video really quick, just so you get an idea how and what this atmospheric electricity is that we've got all over in our atmosphere. Here we go.
I'd previously demonstrated generating power using atmospheric electricity. A hexacopter was used to lift one end of a wire high up into the air. Meanwhile, the other end of the wire was connected to a corona motor near the ground. Electricity then flowed through the wire and corona motor, making it turn. In this video, I'm going to explain how it works. Much of the following explanation is adapted from Nobel Prize-winning physicist Richard Feynman's lecture on physics, a section called Electricity in the Atmosphere. For every meter you go up in the air, the voltage increases by around 100 volts, or we could say around 100 volts per yard. We can draw these voltage increases using what are called equipotential lines. Notice that the ground is negative and the sky is positive with respect to each other. According to Feynman, this extends upward to 50 kilometers, or 31 miles, where the air is very conductive. This is the case in fair weather. In stormy weather, like a thunderstorm, things are quite different, and I won't talk about that here. But if this voltage exists between your head and the ground, why don't you get a shock? The reason is that your body is a good enough electrical conductor that standing on the ground, you're basically a part of the ground. The equipotential lines would look like this. There's still effectively 0 volts between the top of your head and ground. Similar effects happen with trees, buildings, and so on. What about the electric current? A downward electrical current exists and consists of positive ions, molecules or clumps of matter that have a positive charge. These ions are moving slowly.
So did you get that? The positive clumps of ions or matter that take a positive charge, okay? Because the Earth is negatively charged, and the supply of the electrons, or positrons, I guess if you want to call it this, are actually coming down. The positively charged particles are coming down, and they are literally exerting a pressure downward, okay? This is a fact, and we are going to demonstrate this for you very clearly. So this is, again, this is what's happening in the mainstream world, and the mainstream science has no compunctions with this. Like I said, this is Feynman's work, his own work. The only problem is it's not possible on a globe Earth in the configuration that the globe works with space. And we're going to get to that. What it does work in, though, is in an enclosed type of area. So let me play the rest of this and we will continue.
Toward the ground. The current density from these ions is very small, around 10 microamps, or 10 picoamps, crossing each square meter or yard every second. So in any small area, there's not a lot of power. And that's the explanation about atmospheric electricity adapted from Feynman's lectures. To take advantage of this atmospheric electricity, we electrically connect one end of a wire to the ground and lift the other end up into the air. In our case, we got good results at around 120 meters, or 390 feet up. At 100 volts per meter, or 100 volts per yard, that's 12,000 volts between that height and the ground. But just as with you standing on the ground, the wire is an electrical conductor, and so is also at ground potential. Looking at the equipotential lines around the wire, that voltage of 12,000 volts exists between some distance away from the wire and the wire. You can see that the equipotential lines are closest together at the top of the wire. This means the attraction is strongest there, and electrons make their way upward in the wire. Let's look more closely at the top of the wire. We'd put 6 sharp points using sewing pins at the top of that wire, but for ease of illustration I'll draw just one. Notice that because of the sharp shape at the point, the charges are crowded together at that point. Remember also that there are positively charged ions in the air. An electric field exists between the negative charges on the wire and the positive charges in the air. And we can represent that electric field by drawing lines between pairs of opposite charges. Notice that the electric field lines are closer together near the point, meaning the electric field is stronger there. It's strong enough to remove the negative electrons from the sharp point, where they neutralize positive ions. But due to the voltage, there are fresh positive ions moving downward and fresh negative charges coming up from the wire.
Now, one thing I wanted to comment on, just, for quick, is I'm sure a lot of you are familiar with the Iwaranon videos, where he talks about the antiquitech of these long pointed and with multi-pointing wires on them on top of buildings, just like this, right? We've seen these on tops of tons of antiquitech, and what happens when they actually go into action is they're normally in a down position. When they activate, they rise up and they start collecting electricity right out of the air, right? So this is just one way that they used to do this, back in the 1800s. If it was truly 1800s, who knows, with as much as they've lied to us about everything. But the bottom line is that there's evidence of this type of technology being used all over the place in antiquitech, right? They call it antiquitech. So I just wanted to point that out, and let's continue on, and we will finish out here.
Is in everyday life, but it is enough to turn an electrostatic motor, like this Corona motor. The Corona motor consists of a plastic cylinder surrounded by sharp-edged metal blades. Every second one of those blades is connected to the wire going up into the sky. That means that when the wire starts conducting, those blades are now whatever voltage the top of the wire is up in the sky, though opposite in polarity, positive. That's why you get a shock when you touch one of those wires. Negative charge is then pulled from the plastic cylinder through a gap between the edge of the blade and the cylinder. That leaves the cylinder with the same charge, and since like charges repel, a repulsion occurs that rotates the cylinder. The next blade is connected to earth ground and becomes negatively charged, and since opposite charges attract, it attracts the charged area of the cylinder. It then neutralizes that charged area by taking electrons from the ground. And that's how atmospheric electricity can power an electrostatic motor like a Corona motor. Well, thanks for watching.
All right, so there you have it. So that's basically just a little sampler of how we can draw electricity out of the atmosphere today, which is primitive compared to the way that they used to do it back 100 plus years ago, when they literally designed entire cities to collect this atmosphere. And I have a feeling that when Award Anand comes out with this next section, it's going to blow your mind, because I think I know where he's going with it. And he's going, I'm pretty sure he's going to be going the exact same place that I am with it. And, this place was made absolutely to provide us with free electricity. And one of the reasons behind the space deception is to turn people away from the idea that we could, ever draw this type of energy out of the earth and out of space in and of itself, out of this construct, right? Or if they are doing it, they're using it for themselves and keeping it away from everybody else. Okay. So you might want to ask yourself at some point, and here's here's Feynman's book, right here. Oops, wait, I'm sorry, that's not right. Feynman's book is right here. This is the chapter 9 where he's talking about the equipotential lines, and it's called feynmanlectures.caltech.edu, and it explains it all. But let's go over and you might want to ask yourself, well, where is the power coming from that is feeding this downward force of power that's coming down, right? And that's a very, very good question. Where is it coming from? And believe me, they have an answer, but boy, is it dumb. Okay, so Wiki says, atmospheric electricity is the study of electrical changes in the Earth's atmosphere or that of another planet. The movement of charge between the Earth's surface, the atmosphere, and the ionosphere is known as the global atmospheric electrical circuit. Now, first of all, guys, I got to tell you that the ionosphere is bullshit. It's complete crap. It's completely made up. And I don't believe for 1 second that it exists. And the reason I don't is because there's something already there that provides that. Okay. So let's continue on. It says atmospheric electricity is an interdisciplinary topic with a long history involving concepts from electrostatics, atmospheric physics, meteorology, and earth science. Thunderstorms act as a giant battery in the atmosphere. charging up the electrosphere to about 400,000 volts with respect to the surface. This sets up an electric field throughout the atmosphere, which decreases with increase in altitude. Now, guys, do you wonder why that field would decrease with an increase in altitude? Well, I'll tell you why. Because the air pressure, the particulate matter that is in our atmosphere, is getting less and less and less. We are starting to go down, from the PSI range down below 1 PSI, and pretty soon we're going to be down into the torr range. 1 atmosphere is 760 torr, and you can go all the way down to almost, to 1 torr, and then you start going into logarithmic fractions of that, right? So there's a whole lot of deception put there just to keep us from understanding, first of all, how much, particulate matter there is up there, and other things. Anyway, okay, so basically, it decreases with altitude because we are losing air and gas particulates, right? The less you have of those, the less you can create an electrostatic field. That is a fact. You must have particulate matter to create an electrostatic field, okay? So what do they say feeds this top layer, right? This so-called ionosphere. They say atmospheric ions are created by cosmic rays and natural radioactivity moving the electric field, so a very small current flows through the atmosphere. Even away from thunderstorms near the surface of the Earth, the magnitude of the field is on the average around 100 volts per meter. Well, there it is again, that 100 volts per meter. Now, we also have another description of that, and I'll probably take you to this here in a little bit. Actually, let me pull that out really quick. Hang on just a second, guys. I'm trying to get my shit together here. Any questions so far from anybody? I'm sorry?
I was just saying that was a lot of tabs.
Yeah, I know. There's a lot of tabs. I'm bad about that.
Wait, are you saying that even one of the top guys as a globe proponent says there's an electric downward current on the Earth?
Yes. In fact,
Wow.
he's where I found out about it from. Was Richard Feynman. And it is absolutely there. There's no doubt about it. And like I said, I discovered it in my own way by, when I worked in microwave and satellite, I also did a lot of tower work. And when you go up a tower, 200, 300, 400 foot tower, and you accidentally, you're hanging up there 400 feet in the air. And if you accidentally come across something that is grounded, like the outer braid of a coax shield, and you touch it, that shit will knock you on your butt. Big time. You get a huge electrical shock. So the charge is absolutely real. It's absolutely up there. There's no doubt about it. And the really amazing thing about it, Austin, is that it is so perfectly linearly fashioned. These equipotential lines. Isn't it amazing that throughout all of these, what they're going to say actually does this? These huge inputs of voltage coming from cosmic rays and cosmic X-rays and stuff like that is somehow balances out, and it acts exactly like a capacitor. So
that makes sense, bro. Cosmic waves, man, made a perfect capacitor. Duh, science.
Yeah, it's absolutely amazing. So the way
hit exact cosmic rays the same amount at all times to keep our field so linear. And I mean, the electric field also pulses every day at the exact same time. It's like a heartbeat. They call it the Schumann resonance. So I think it's 4 p.m. UTC, it starts increasing, and at 7 p.m. it maxes out, and then by 1 a.m. it goes back to normal again. But this is every single day it does this, like a heartbeat. Now, to say that that's from all these random rays coming in from all this stuff, no, I'm not buying that.
No, that's right. It does. There's an absolute heartbeat to it. It's an amazing, 1900 UT. So it's 7 o'clock. And they explain it. They say because there's more land mass in the late afternoon than during other times of the day, such as 4 o'clock UT when the Pacific Ocean is in late afternoon local and the global circuit is at a minimum. So it's like, what the hell does that have to do with landmass? But if you guys watched a show we did a long time ago called Sunday Mass, well, we revealed in that really science doesn't have a really good definition for what mass actually is. And there are so many different viewpoints of it that they can't even make any sense of it themselves. Every single PhD physicist has a different take on it, which is different than Einstein's take, which, says, well, if you add motion to it, then mass becomes infinite, on and on and on. It's just it's a mess, right? It's a mess. So where do they say that we get it? Okay, so what was the source of the large-scale electric field, and why was it not quickly reduced to zero by charges in the conducting fluid? What was the source of the conducting fluid? Or, in other words, why didn't the large-scale electric field sweep away all the free charge in the atmosphere? Another critical discovery came in 1911 when Victor Hess was conducting atmospheric electricity experiments to study radioactive ions in the air. Using a balloon experiment, he found that the conductivity increased with altitude rather than the expected decrease. Now, this is a mainstream document, so geez, isn't that amazing that they would say that, okay? Thus leading to the discovery of cosmic radiation. And they're saying that these cosmic radiations, is it this one? Actually come up to like 1 giga electron volt, this huge amount of electrical power that's coming in, which clearly is not coming in. And even if it was, it would be blocked. How do I know that? Well, I know that because of this. You guys have to remember this because I've used this so many times. The invisible shield found thousands of miles above Earth blocks killer electrons. So, we had this brought out by Colorado State University or University of Colorado at Boulder. And it was verified by Massachusetts Institute of Technology and a host of other people. When basically, they came out and said, wow, this is so weird, but there's something up there at 7,200 miles, and it's blocking all these electrons that are coming in, these killer electrons, this source for the field that they're telling us is providing this perfectly stable 100 volt per meter Gaussian type of surface. Well, sorry, Charlie. This isn't the only time that they contradict themselves either, by the way. When you read several of these articles, at some points they will say that it's there, other points they won't. Of course, why do I say that the top layer or the bottom layer of the firmament is actually at about 62 miles? Well, because so many things happen at 62 miles. One of the things is the alleged sodium layer, right? Of the laser guide star where they can, apparently shine a laser onto the sodium layer of the atmosphere and it will fluoresce an artificial star with low magnitude or high brightness so that they can then correct the distortion that's created by the atmosphere, right? We also have sprites and elves, right, which discharge in an upward direction. And again, in order to have a discharge from one area to another, in other words, when they see these discharges from a cloud, well, we know where one of the area the discharge is coming from, and clouds will definitely accumulate a charge because of friction in the atmosphere, et cetera, et cetera, et cetera. But the odd thing about it is they discharge up, and when they do discharge up, they all flatten out perfectly right at about 62 miles, right? So I'm convinced that there's something there at 62 miles. What is it that I think is there? I think that it is the top Gaussian plate of the firmament. So let's listen to this guy and talk about equipotential surfaces and what he says about Gaussian plates. And then we're going to cover some more of this stuff because I really need to get this through to you guys. This is so obvious. This is what mainstream science tells us we already have, but their explanation for it is ridiculous, and our explanation for it makes perfect sense. Here we go.
And don't they Bob, that at 62 miles up, there's also a sodium layer? Isn't where they say that sodium layer is at right about 62 miles?
Yeah, that's exactly where they say it is. That's 62 miles. That's what they fluoresce with the lasers.
That's like salt water, a sodium layer.
Yeah. Yeah. And I'm not sure. Maybe it'll light up, and maybe it won't. But why in the world at 62 miles where, I don't even know what the what the torr is. It's probably 10 to the negative sixth, something like that at that altitude. Why would there be a layer of sodium there that's light enough to be able to fluoresce it? That makes no sense. Where is this particulate matter coming from, and why is it sitting there? They have no answers for that. They're just making stuff up. Point blank. So, all right, so let's listen to this guy and what he says about this, and then we're going to talk a little bit more about Gaussian surfaces.
Welcome to Electron Line. Now we're going to talk about equipotential surfaces. So let's assume we have two metal plates, one that has positive charge on it, the other one that has negative charge on it, that kind of like capacitor plates.
Okay, kind of like capacitor plates. And again, positive, let's flip this up to the top, negative down to the bottom. And these become Gaussian surfaces or capacitor plates, however you want to look at it. Remember how capacitors work.
And so there's an electric field between them directed from the positive to negative charge. And also assume that on one end we keep the potential at 0 volts, and let's say therefore the potential on the other end is 100 volts. So there's a 100 volt difference between them. Remember that the electric field strength is equal to the ratio of the change in the potential divided by the distance over which we travel. So the distance would be this distance right here. So in this case, we can say that the change in potential, E times V, is equal to the strength of the electric field times the distance over which we travel. So that causes this to be 100 volts based upon that the electric field strength. So let's say, for example, that D is equal to 10 centimeters. So in that case, we can say that here we have 100 volts potential difference divided by 0.1 meter, which is equal to 1,000 volts per meter. So that's an indication of the strength of the electric field. For every meter traveled between those two plates, the potential will change by 1,000 volts. Or you can say that the change in potential is equal to the strength of the field, which is 1,000 volts per meter. Travel 0.1 meter, that would be equal to 100 volts. Which would also mean that if you travel a shorter distance, let's say only 2 centimeters, so the delta V would be equal to 1,000 volts per meter times 0.02 meters, in other words 2 centimeters, that would only be 20 volts. So for every 2 centimeters traveled, the potential will drop by 20 volts or increase by 20 volts depending upon which direction you go. So if you go from here, you travel 2 centimeters, then the potential at that location would only be 80 volts. So this would be 80 volts. Travel another 2 centimeters, now this would be 60 volts. Another 2 centimeters would be 40 volts. Another 2 centimeters would be 20 volts. And eventually you get down to 0 volts. So these lines that I drew here, now of course these lines really represent surfaces because these are plates that are parallel to each other. So these are like regions or planes or surfaces. So all along that surface, the potential is 80 volts. All along the next surface, it's 60 volts and so forth. So these are what we call equipotential surfaces because there the potential is the same, equal, and so we call them their equipotential surfaces.
Okay, actually, they're Gaussian surfaces, but whatever. What they produce is an equipotential, perfectly linear, predictable voltage at a specific point in space. Well, you got to ask yourself, how is it that we can make these predictions and then verify those predictions with our measurements, like 100 volts per meter? And it doesn't vary from that very much, guys. The biggest variation is 1900 UTC. where there's the biggest variation from that, and that's all in Richard Feynman's paper. But you have to ask yourself, how is it that they're able to get that 100 volts per meter and standardize it if something isn't providing a continuous feed at the exact same voltage virtually all the time on the top side of the feed? Because the Earth sure as heck isn't changing, its potential or anything like that. Earth is ground. Earth is where the electric voltages return to. So again, you have to have something that is providing the electrical charge, the charged particulates, the charged matter itself, in order to be able to even predict this at all. And yet they do. So let's listen to a couple more minutes of this, and then I'm going to switch over to another one.
Now, what's interesting about them is if you travel along an equipotential surface, if you travel along that surface, the potential doesn't change at all. But in other words, if you take a charge and you move it along an equipotential surface, there's no work involved because the potential doesn't change. That means you're traveling perpendicular to the electric field. So it's
right. And the same goes for when you travel along these equipotential lines. If you take a hot air balloon up to 1,000 feet, right, and you basically get, a voltage there, and you take a voltage measurement there, and then you just migrate sideways, to left, right, forward, backward, whatever, that voltage is not going to change. It's going to remain the same as long as you don't change a vertical elevation. Now, there will be some small variances, but nothing of any great concern, right? So again, it's like, wow, for something that just exploded, from nothing into everything, this seems like an incredibly constructed type of electrical field. Why would that be there? What could it possibly do? Why is it there? Well, we're going to get to that. Let's continue.
It's really important to notice here that equipotential surfaces are always perpendicular to the electric field, and therefore traveling along equipotential surfaces means traveling perpendicular to the electric field means it requires no work if a charge is moved along an equipotential surface. All right, so hopefully that gives you a feel of what equipotential surfaces are. Potential doesn't change. Work is not required to move from point A to point B. Let's do a quick example. Let's say that...
Okay.
Yeah, what he means by work is not required, it means that the force of the electric potential, it'll move along with that force. So if you put something like right underneath that first red line where that E is, it will move to the right and it'll do it all by itself without any other force applied to it. Now, if you wanted to go from the right to the left, you would have to add force to go against that electric field. It's like lifting something up in the air. You have to do it with force, but when you drop it, you just let it go and it follows those equipotential lines down to the negative surface.
You're right. And what a perfect time. I didn't even have this in here, but what a better time for this. I feel like everybody's seen this a million times already, but University of Bristol spider ballooning. Oh hell, what did I do? Did I goof?
So
wow, what the hell did I just do? I hate it when I do that.
Yeah, I think you clicked on a video instead of the search.
I think I did too. My bad.
Watch party.
Yeah, this is so cool.
And I know a lot of you guys have seen this, but what this is going to show us is this, first of all, is what so many creatures in nature use this electric field for. This electric field is also what we call gravity. It is providing a continuous downward force. And when we get to Zack's video, we're going to show you exactly how it does that and how it can be overridden. And we've already done it. We've already overridden it experimentally. It works because gravity is electrical. And I've been saying that forever. And without it, again, without that initial downward bias, nothing works. But so one of the things that it's used for, well, first of all, NASA tells us that they tether their satellites. Well, and they actually do, but they tether them on hot air balloons. And the way that they do that is when they send a hot air balloon up to, say, let's say 150,000 feet, somebody do the math, whatever, and that'll tell us what the equipotential voltage is up at that value, okay? And then they drop a long tether off the bottom of the balloon, and they energize that tether with a different voltage. It will cause that balloon to either rise or fall, depending on how the charge is applied and how much of it is used. Okay, spiders do the same thing. And again, this is just a fantastic demonstration because this is useful in so many ways to understand this. And I'm sorry if you're sick of it, but it's only 3.5 minutes, so let's watch it. And
real quick, that we're able to go to Flatoberfest and visit Cami and I's table. This was actually one of the demonstrations that I had. I had the Van de Graaff generator hooked up to some balloons that were tethering a button pin, and then I ran a cable to it and ran a charge to it, and it would just drop right down to the ground. I would discharge it, and it would lift the button right back up off the ground.
Yep, that's right.
So yeah, we demonstrated this too in front of people.
Yep, because you're able to override it.
Oops, and I'm going to jump in really quickly with if you go to Kyle Adams' most recent video, he's going to show how it affects the light, the electrical field affects polarity and the light, and how bees also navigate by it. And he shows that and does a nice demonstration. I'm going to jump back out now, but that also ties right in with what you're doing.
Oh, okay. I thought you meant that his latest video was Globebusters is number 20.
That was a great video too. His video that shows with the light polarity and such, the one prior to that.
Yep. Okay. All right. So let's kick this up just a little bit and let's watch this.
Of all the great flyers the world has ever known, it may come as a surprise that one of the best aviators in the animal kingdom doesn't even possess wings. Spiders, instead, use long fans of silk to carry them through the air, often for many hundreds of miles, in a process known as ballooning. They have long been known to have flown the nest in such a way. Charles Darwin himself marvelled at hundreds of tiny spiders landing on the Beagle while out at sea, and later recorded how they took off from the ship with great speeds even on a calm, windless day. During this time, there were two theories for how ballooning worked. The first theory, and the most obvious explanation, was that long strands of silk emitted by the spider catch the wind and the associated drag forces pull the spider aloft. But spiders will only balloon on days where the wind is a gentle breeze, which raises the questions of how there'd be enough force to pull the silk from the spider's spinnerets, and how could heavier spiders even become airborne at all? The second theory was that atmospheric electricity could also provide the force needed to get the spider aloft. Similar to how your hair lifts to stand on end when you rub a balloon on your jumper, spider silk could be lifted into the air by natural electrostatic forces in the atmosphere. These electric fields are present at all times all around the world, but are most noticeable during thunderstorms when they are at their strongest. Surprisingly, until now, the electrostatic theory of spider ballooning had never been tested. In our lab at the University of Bristol, we isolated spiders from any airflow or atmospheric electricity and generated our own controlled electric field at levels found in nature. In response...
Guys, if you're curious how they developed their own, what they did is they made a very large cage in which the bottom they put a bunch of Gaussian surfaces, or basically metallic surfaces that act as electrical conductors. Okay, and then what they did is they applied a super high voltage charge either from a Tesla type coil or a Van de Graaff generator that would be in the hundreds of thousands, probably in the millions of volts, because you have to understand, in order to override that field, and I wish they would have actually done this too. We're going to try and do this experiment ourselves. But in order to override it and flip it over, you've got to overcome the potential of voltage that is there in the first place, right? So what they did is they hooked up their own Van de Graaff generator to this cage, and they then allowed the spiders to get set free in there. And of course, the spiders automatically detected that electrostatic field with the little hairs on their legs. They actually stand up, which is amazing. So that's how they did that. And then, let's continue.
The spiders began to change their behavior to...
Okay.
Bob, yeah, I just want everybody to remember what the guy said about where the electricity gathers most. Remember, when he was showing that video of the thing he stuck up in the sky, he said at the very tip, at the point, that's where most of the electricity gathers. You'll notice none of these spiders will start ballooning like from the center of a flower. They always walk out to the petals near the edges, because that's where that negative electric field from the ground is strongest, and that's where they gather most of it from.
Right, because they need to isolate themselves as much as possible from everything else that's acting as a Gaussian field. Right.
Yeah.
Yep. So here we go.
So cool.
Perform tiptoeing, where they straighten their legs, raise their abdomen, and release silk. This behavior is only ever seen when a spider wants to balloon. Furthermore, once the spider was aloft, its altitude could be controlled by turning the electric field on and off. This demonstrates that spiders can balloon using electrostatic forces alone.
So there they have it. When they turned off the field, the spider just dropped, right? Essentially because they were isolating. They probably didn't turn it off, but they were turning off the overriding field that was in there already, or equalizing it, and then the spider would just drop. And again, NASA does the same thing with balloons. It can definitely be done with balloons. And there's many other things that can be done with this, I'm absolutely sure. But yeah, we're most familiar with this from seeing, all this new information coming forward in Antiquitech, which is amazing. But the spiders, here they are. They're just little bugs, some of the best aviators in the world.
But in all likelihood, they would use a combination of both wind and electricity to balloon in their natural environments. So how do the spiders detect these electric fields? In this experiment, it was also observed that the minute sensory hairs on the spider's exoskeleton were similarly moved by the electric field. We can then infer that spiders can feel the charge in the air using the same sensory hairs they would use to detect a breeze. The results of this study show us that electrostatic forces could be an integral part of spider ballooning, and by fully understanding the mechanisms behind it, we can better describe population dynamics.
Yep, and blah, 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 blah. So, there you have it. Isn't that interesting? And I just find that absolutely fascinating. And of course, there are so many creatures that use not only sensing of the electrostatic field, but the electromagnetic field as well. Just in their daily routines. It's kind of crazy, but one of the first times I ever heard about dogs, one of the things, and you actually watch your dog, and not all dogs do this, but most dogs do, but when they go out to use the bathroom out in the backyard, watch them, and most of the time they will turn to the north, which is interesting. Why they do that, who knows, but it is pretty wild to see.
Yeah, Minion did it last night, and he's standing facing the wrong way on a hill. So he's facing to where he's getting ready to tip over forward because he's trying to do this, and the ground is closer to his butt because he's facing down the hill, but he's facing north, and he does this all the time. It's crazy.
Yep.
Hank does the same thing too. Hank faces north.
Yeah, a lot of dogs do. So you might want to watch your dog on that, because it's kind of funny. That they do that stuff, but it's just something that a lot of nature relies on this stuff. This field was put there for a purpose, and frankly, ladies and gentlemen, I don't think that we could survive without this electrostatic field. There's no way you can go out into space. There's no way you can avoid it. And I think if you did, your own power source, which would be this field most likely, would shut down. I think it's the power source that animates most things here on Earth. Of course, can I prove that? No. I think that, and I have a lot of good reasons for thinking that, but, I'm not going to claim it as absolutely positive, but, it just seems to make a lot of sense, as most things, because the more we find out every single day how much we've been lied to, the more these alternative explanations seem to make a lot more sense. And like I said, when it comes down to the electrostatic field in the Earth's atmosphere, oh my God, the Earth experiment is just ridiculous. The Earth reasoning for it is ridiculous. So, all right. So what I want to go next to, we already did that one. Is it this one? I think it's.
Wait, can I just say real fast as a overarching thing, right? Like, do we have proof positive of exactly everything that's going on regarding the electric field and all the phenomena? Maybe not. Same with the background, right? But the part that I hope that truthers really take in is it's seemingly the only viable option. It's the only viable route. So you have the option of ignoring the phenomena entirely or starting off with the foundation of viability, right? And so I think we shouldn't be fooled into taking the ignore the phenomena route, because we're all here because we want to know more about where we live, right? So we should compile what we know to be true and put the pieces together based on viability and go from there. I just want to say that because it seems like some people would rather take the turn their head route, and that doesn't help anyone really,
Yep. Yeah, I absolutely agree, Austin, and you're right. And again, the explanation in the flat Earth model is so much more simple, and there is so much evidence for it. It's just like, the Globers. Oh yeah, show us evidence of your firmament. How many shows have I done? Showing not only the NASA, U.S. Army, CIA documentation talking about the firmament, but all the weird things that happen at 62 miles. The sodium layer, the ionosphere area that's supposedly bouncing around up there, sprites, elves. There is something absolutely positively there. And the fact that every time we watch a launch, they all arc off before they get anywhere near 62 miles. So, yeah, that's why I'm saying we're proposing this. And like I said, I don't give a damn what the Globers think. And I'm not going to compare this to their model because they have no proof for their model at all. Unless they want to take, what NASA says, and NASA lies about everything as gospel truth, and nobody can prove anything that NASA says, and that's just the way they like it, right? So here's another little bit on electric fields that I want to cover before we move on to Zack's videos, but just so that this gets embedded into everybody's head, about what's going on with these electric fields. Let's go ahead and play a couple minutes of this, and then we will move on to Zack's video.
Last time we talked about how charged particles exert electrostatic forces on one another. We calculated these forces using the charge of each particle, which can be either positive or negative, and the distance between them. And we did it with the help of Coulomb's law, the equation that tells us the force generated by two charged particles on one another. But what if we want to talk about more than two charges?
And by the way, the math equations doing this are virtually identical to the equations that calculate gravity. Gee, that's just coincidence, right?
Yeah, the equation is exactly the same.
Yes, it is.
I mean, there's no real difference at all.
Yep.
Yeah, it's crazy.
But people buy it. We're just going to swallow it up because that's what NASA tells us. Let's continue.
Or if we're dealing with charged objects of various shapes and sizes. Coulomb's law is great for finding the force between small objects like particles, but in physics we deal with all sorts of shapes and sizes. Electric forces are used to bring power to your home, charge your computer, and light up the screen that you're using to watch this video. These everyday electric phenomena require physical components that manipulate charged particles in amazing ways. We make electrical components that excite millions of electrons in each pixel on the screen. But how do we design them to transmit just the right amount of electric force. We've got some equations and concepts under our belt already, but we'll need a few more to understand how to control charged particles and expand the possibilities of electricity.
And by the way, we are using this for commentary, for educational purposes, and all that other stuff that goes along with fair use, because we are definitely doing this in the course of a science lesson. Let's continue.
We want to describe complex situations involving charged particles using more than just Coulomb's law. If we have an object with a known amount of net charge, can we predict how other electric charges will react when they pass nearby? Well, British scientist Michael Faraday came up with a way to do just that. He hypothesized that every charged object generates an electric field that permeates space and exerts a force on all charged particles it encounters. And
Okay, so what she just said is he hypothesized that every charged object generates an electric field that permeates space and exerts a force on all charged particles it encounters. Now again, guys, when you go up into this alleged outer space where you have vacuums of 10 to the negative 17 torr, where it takes the power is unimaginable. In fact, we can't even get to half. We can't generate, with all of our best equipment here on Earth, we can't even generate half of what it takes to get to that level of vacuum in outer space. In other words, there's nothing up there to charge. There are no particles to charge. It is essentially void. Yeah, 10 to the negative 17 particles. It's got some particles in it, but in comparison to the rest of mass, there's nothing there to charge, and especially nothing that is going to handle the 100 giga electron volts that they say are feeding the incoming cosmic rays for this equipotential force that makes it down to the ground at 100 volts per meter. Just doesn't happen, guys. So first of all, we got Faraday saying that, and you can take that to the bank. But with that caveat, on all charged particles it encounters. No particles, no charge, folks. Let's continue.
Particles it encounters. And he was right. An electric field is a measurable effect generated by any charged object. The field carries energy and passes it on to other charged materials by exerting electric forces. And we can get to know how electric fields work in a couple of different ways. First, there's good old math. Let's consider a positive point charge, which we'll call capital Q. To study the effect that big Q has on other charges, we'll bring in a small positive test charge, small q, and measure the force that's acting on it. Now, when we express it as an equation, the electric field created by a charged object is the electric force between the object and the test charge divided by the magnitude of that test charge. To find F, you just have to use Coulomb's law, and you only need to know the value for big Q, the point charge. In fact, you can plug the equation for Coulomb's law into this equation in place of capital F. And if you do, you'll see that the magnitude of the test charge cancels out, and we're left with an expression that relies solely on big Q. Now we've got an equation to calculate the electric field generated by any point charge. But let's make this field even easier to picture. Another way of understanding what's going on between these charges is to diagram it with vectors, using what we've learned about Coulomb's law and force vectors. Again, let's start with our positive point charge, capital Q, located at point A, and our small positive test charge, small q. While both big Q and small q generate electric fields, we're going to assume that big Q has a much larger magnitude than small q. Now let's plot a series of vectors that...
Right, now when we get to Zack's video and we start using the Van de Graaff generator to basically flip the polarity of gravity, we would, if we were to do the math on it, we would be applying these equations to it, because what we're doing is we're manipulating the electrostatic field, down here where there is an electrostatic field. Okay, so I'm not sure this really has much left in it that we need. I'll play it for about another minute, and if not, well, then we will move on to Zack's video.
result from placing small q at various points around big Q. These vectors are called electric field lines, and their purpose is to show the magnitude and direction of the force exerted on any nearby positive test charge. The density of these field lines signifies the magnitude of the electric force on small q, and the closer small q is to big Q, the greater the force. And the same logic applies to how we represent negative charges, although we do implement it in a slightly different way. The electric field line diagram for a fixed q that's negatively charged would look like that of a positive q, but with arrows pointing inward to...
Yeah, okay. I don't think we need any more of that. Okay, so basically, to sum it up, guys, we have a couple different things that we've learned today, right? That we have this equipotential static field that goes up in a very nearly perfectly linear form from 0 volts on the ground to 100 volts at 1 meter up, 200 volts at 2 meters up, 300 volts at 3 meters up. Feynman says it's been measured all the way to 50 kilometers, which is 31 miles. And I'm saying that the firmament is exactly double that. The bottom layer of the firmament is exactly double that at 62 miles. And that basically gives us a 10 million volt electrostatic field potential between the firmament and the earth. Now, these voltages can become additive and subtractive, and they can build up to much larger charges, depending on things that are going on in the atmosphere. But the bottom line is that underlying this is always that voltage. It's the voltage that everything runs on. And in addition to that, guys, and I don't have any scientific backing for this. You just have to, I'll say it and you see what you think about it. But you guys all know that I've said that, if astrology is truly a science, and I really do believe that it is, and it is the study of trying to understand how these lights or these energetic points of light in the sky, in specific configurations in the matrix, affect us and our health, our mental aptitude, our physical abilities, our luck, all kinds of things, everything that goes along with it. Then this is something else that is kind of integrated into this equipotential static field, right? So we have the field that powers us and everything on Earth, basically. But then we have this amazing combination of celestial alignments, which are kind of overseeing our daily energetics, right? Now, if you believe in that, great. If you don't, that's okay too. It doesn't really matter. It doesn't change the fact that the electrostatic grid is here, it's real, and the mainstream explanation for it is retarded. Okay, so let me...
Yeah, it's never been recreated ever, like the ionosphere. In a vacuum, getting one charge to travel from one object to another in a vacuum has never been done. And I've only found 3 papers where physicists have brought this up, and this goes back over 100 years now. And there's only been 3 physicists that write, hey, why is Maxwell's equation, first equation and fourth equation, contradict each other?
Yeah.
So how many of these physicists actually know what they're talking about and actually comprehend what these equations really mean and don't just memorize and regurgitate them?
Yeah, exactly.
Scary when you think of...
Yep, it absolutely is. Okay, so, all right, so there's Zach's video. I don't know why I keep closing that accidentally. All right, so this is going to take us now to Zach's video, which he made last month. Wow, yeah, about a month ago. And this, I got to tell you, Zach, you did a great job on this. He and I talked about this for a long, long time, and it pretty much gets everything we would ever want to know about this into the main picture here. And Zach, at any point, if you want me to stop, you want to do commentary, go ahead and just say so. But otherwise, let's go ahead and watch this video and pay close attention to this, guys, because this really does put it all together for us and how it works, the downward vector. Here we go.
Hello, everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala if you prefer. In this video, we will be explaining how incoherent electrostatic acceleration creates the downward vector. Gravitation, a word which many do not comprehend, is a theory that was created to explain the paths of the luminaries above, and what keeps them in orbit around other bodies, including our Earth. It has been known and taught in college-level physics courses that the electric forces that hold the Earth together are 26 times stronger than the gravitational forces that are supposedly here on Earth.
Just real quick, Bobo.
Yep, go ahead.
It is 10 to the 26 times stronger, not just 26 times stronger. I made a mistake there.
Oh,
yeah,
that's
so
okay.
they're
What is that weird noise?
I
You
don't know,
sound-
I hear it as well.
You have a cat inside the bag?
That is the weirdest noise.
Is it
Mute
awesome?
I don't know who it is. Mute. So, you guys mute your mics.
I'll mute.
Oh, I think it was Cami. It's Cami. Cami, keep your mic muted. Okay, it's gone now. Well, no, it isn't. What the heck?
You are living with an alien, man.
That is freaking weird, man.
That is Cami. I'm
Says
Cami.
Cammy's not muted, so I don't know.
Yeah, Cami, make sure you're actually muted going into Skype. I have no idea what that is. That is freaking weird. Anyway, okay. Oh crap, what was I going to say? One thing that
I was
I want
just
to
saying 10 to the 26 times stronger, not just 26 times stronger. Yeah.
Right. Okay.
That's where I was.
And the other thing that I wanted to say about this is that, you know how they basically attribute this to Newton, right? And with his constant G equals 6.67 times 10 to the negative 8 dynes per centimeter squared per gram squared, also called gravity regarding blah, blah, blah. Okay. Now, Newton said he did not want this silly ass theory ascribed to him in any way, shape, or form, because to him, it was spooky action at a distance, right? And he would never buy that. It's kind of like removing the ether. If you remove the ether and you have, no field to wave or nothing to perturbate, then it's pointless. All you have is a description of a motion with it affecting nothing. So, yeah, that's something that Newton didn't want this ascribed to him at all, but they still talk about it like he came up with it. But so let's continue on.
Stronger than the gravitational forces that are supposedly here on Earth. I will now show you a short video of former MIT physics professor Walter Lewin explain this quite clearly.
So what holds our world together? Well, on the nuclear scale, 10 to the minus 12 centimeters, very important are the nuclear forces. On an atomic scale, up to thousands of kilometers, it's really electric forces that hold our world together. But on a much larger scale, planets and stars and the galaxy, it is gravity that holds our world together. And now you may say, that's very inconsistent with what you just told us, because didn't you tell us that D cancels if you compare gravity with electricity?
Yes, but keep in mind that most objects in the universe have only a very small amount of charge per unit mass. The Earth and Mars have each a charge of about 400,000 coulombs. The gravitational force between them is therefore about 17 orders of magnitude larger than the electric force.
So even though our immediate surroundings...
So basically what he's saying right there is that electricity, even though it is orders of magnitude way stronger than the supposed gravitational effect that they claim, the mass attracting mass one that is a complete fiction, he's saying, well, even it can't do it. So this is where I get into the area where this is completely made up stuff. Again, they're polluting young minds with it. It's not right, but they're doing what they're doing. And, hopefully some people will be able to understand this and see around it at some point. Let's continue.
Right, just to clarify, what he just said was that what we know is actually there and can prove. If we take it out to this fairy tale scale of this universe, it wouldn't work. So we need to make up another force that would be 10 to the 17th power stronger than that. So we must assume it's there.
Exactly. And thus their search for dark matter and all this stuff and their assumptions that it's there. Well, it has to be there. Why does it have to be there? Well, because it does. Otherwise our math doesn't work. And it's like, well, maybe your math's bad. Or maybe your overall premise is bad, It's like, it's unbelievable. Like I said, people just have simply lost the ability to think critically, and it amazes me. They are so hypnotized by the mainstream brainwashing. It's awful. Anyway, I digress. Let's continue.
Surroundings are dominated by electric forces, including your own body, for that matter. The behavior of the universe on a large scale is dictated by gravity.
As you heard the professor state, gravity does not take place until we start talking about a moon orbiting a planet, the planet orbiting a sun, or stars orbiting the center of their galaxies.
And right. And of course they would say that, right? Because nobody can tell that, right? Nobody can refute that. We don't know what's going on there. We don't know what is propelling those lights around. What we're pretty sure of is that these things are not terra firma. They are energetic points. What the nature of them is beyond that, nobody knows. But I seriously doubt that they have anywhere. Well, there's just no way that they have these masses that they claim that they do. And therefore, all the attributes they stick to them are really just nonsensical. And again, this is where when you're NASA and you're science and you use that word science says that, this is the mass of this, and therefore it's going to have this manner of attraction, gravitational, blah, 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 blah. They can get away with that stuff because nobody can test it. Now, the beautiful thing about what Zack and I are proposing here is that we can test it, we have tested it, and we can prove even by reversing the gravitational effect by reversing the field itself. What more do you want? I mean, come on. What's the better theory? One that you can't prove anything, or one that we have every single element that is at question that we can vary? There it is. Let's continue.
We agree that this is a theoretical concept that is unproven still today, and find it odd that they need ideas such as dark matter to make up over 90% of their model to explain how it is possible. Having said this, I completely understand people's reluctancy to use gravity in any kind of discussion about the place we live. At the same time, most people who have never been educated on the subject correctly believe that the force holding things in orbit and the force making things fall are one and the same, in which lies the problem. It is hard to explain how this place works when most do not know how the laws of electricity control the world around us. I will try in this video to explain how incoherent electrostatic acceleration works while using examples that can be recreated by anyone. To start out, we will take a look at Earth's electrostatic field. This is important because we, along with all the matter in this known realm, are inside of an electrostatic field. The Earth itself has a measurable negative charge compared to the air above it all across the plane. As soon as you leave the surface, there is a positive charge in the air around you that grows in electrostatic potential the further you go up towards the sky. It is a steady, gradual rise in potential, which tells us, according to the laws of electricity, that we are between two Gaussian surfaces.
Yeah, exactly. It tells us that we're pretty much in between something that is artificially created or divinely created, however you want to look at it. regardless, it is technology, and it is very simple technology. It is an electrostatic field generated by two Gaussian surfaces, and everything else has fallen into place. They've given us everything we need to then work out what gravity is, to work out how spiders fly, to work out all kinds of things. Isn't it amazing? Let's continue.
A Gaussian surface is simply a surface that encloses or distributes a charge.
And by the way, guys, Cami mentioned something that I thought was pretty interesting. In a lot of Freemason lodges, you see the checkerboard pattern a lot, right? And that's exactly what a Gaussian surface is. It's basically an energy matrix, right? So are they portraying Gaussian surfaces in the Masonic lodges? I would say there's a good chance of it. There it is, just all hidden in plain sight.
You have a multiple meanings of every symbol. In fact, I don't know if the Freemasons are created before Gaussian itself, right? But it has multiple meanings.
I agree. Yeah, and you're right, but it seems like everything they do has multiple heads on it. You know what I mean? It takes on
and
many,
in fact,
many
they one of the main symbology behind the black and white square is the duality, and the electricity is it's dual, right? It's positive, negative, so everything is related at the end.
Yep, very true.
And most of these guys, these great electrical minds in our history books, recent history that supposedly came up with all this stuff, all were into ancient India, Arabic writing. They could read Sanskrit, all of them. So I don't even think that Gauss himself, I don't know if he was one of the guys actually, but most of this stuff had already been discovered. I mean, there's ancient Sanskrit that shows you how to make an electrolysis machine to clean your water and stuff like that. So they knew about electricity. I think it was just rediscovered, if that history is even, correct.
Yeah, exactly. As we're finding out, so many things are. I don't know if you guys have seen the newest Jeran video. It's a little bit of a departure from his normal format, but again, he makes some really, really strong points with it. And I think where he's going is he's going to go right down the same line, and we're going to find that so much of this stuff has already been in existence and just been held from us, but in the end, right, supposedly, whether this is the end or not, I don't know, but in the end, supposedly everything is supposed to be revealed. And one thing I will say about that is at this point in time, the Earth seems to be getting a little bit better, but that's all I'm going to say about that for now. So let's continue.
If there were only one surface, the rate at which the positive potential grew would be different. Knowing that we are between two Gaussian surfaces, we can also know that certain phenomenon will take place in all matter within the electric field, or area between the two surfaces. For this topic, we will first look at polarization through electrostatic induction. Electrostatic induction is a phenomenon where the positive and negative static charges on matter are slightly separated or polarized due to the electrostatic charge of its surrounding area. If one set of the object's surroundings is positive and the other negative, the negative charge on the object will be attracted to the positive area around it, while the positive charge on the object will be attracted to the negative area on the opposite side. So here on Earth,
and that, by the way, guys, is called the dipole alignment theory, and this is the take that the electric universe guys had on what creates gravity, which is very, very similar to what we're talking about. But just to let you know that there are mainstream physicists in there that are pitching this and that also believe that this is the way that it works. Let's continue.
The positive charge on our bodies is always attracted down towards the Earth, and the negative will be attracted to the air above. This phenomena creates a slight force in that downward vector, because as soon as we leave the ground, we start becoming positively charged by the air around us and are now forced towards the negative of the ground. This is electrostatic acceleration. One might think that the attraction from above and below would cancel out completely, but it is the electrostatic gradient that creates a flow from the positive above to the negative below.
Okay, one thing I want to say, guys, Zack specified, he said, when we leave the ground, we start taking on a charge that is, above that 100 volts per meter, right? And while that is true, I also want you to know that the Gaussian plate for the Earth is likely around 8 miles down, right? That one plate that we can't seem to get through, it's likely down there, and it's likely that's the material that we can't get through. And of course, if you guys remember Chris Monk Sele, he talked about the materials and the construct of that thing, and it was absolutely perfect for this type of application. But we don't necessarily, we have to leave the surface to pick up a charge with respect to earth ground, but as far as just standing on the surface, we still have that energy exerted down on us. And how do we tell that? Well, it's in the form of weight, right? We weigh something, we're still exerting a force on the ground. And it is because of this very next thing that he's going to talk about, where he's going to say that essentially what's happening is these downward accelerated ions are pushing down, not pulling, but pushing down. Things don't seem to pull in the universe. They more likely push. Is that correct, Zach? Is that what they were?
Yeah, once L beyond the imaginary curve say that, and then you start applying it to how nature works, everything is from positive to negative. People say, oh, you can pull a trailer. Yeah, but the explosion happening in the piston that's starting that whole process is a push. Everything is a push
initially
at the beginning. Yes.
Yep. So, all right, let's continue. I'm going to back this up just a little bit. There we go.
That the attraction from above and below would cancel out completely. But it is the electrostatic gradient that creates a flow from the positive above to the negative below. Think of the Earth as a flat strainer, and there is a constant flow of water from above, moving very slowly, always applying a force in a downward direction. This would be considered a vector.
And guys, I say again, this is not hypothesis. This is fact. We can prove this experimentally, and he does right in this video. And we're going to show you that. So let's continue.
The electrostatic potential difference getting stronger as you rise from the Earth will keep a steady pressure from above at all times until it reaches the Gaussian surface above. When we reverse the polarity of the electric field and put a negative surface above a positive one, we can reverse this electrostatic phenomenon and get things to stick to the upper plate as if it were the ground. This works with all types of matter. You can move wood, iron filings, and even human hair with these forces. Believe it or not, you can even get water to bend. If the vector lines created between the two Gaussian surfaces are curved, all the matter will follow these field lines as well.
Take that, Globers. Leave it to a flat earther to figure out how to bend water.
Yeah, and you'll notice I need two curved surfaces to bend the water. It's following the vector lines. Like the guy said earlier in that one video, matter will always lie 90 degrees perpendicular to the electric field lines.
Yes.
So they'll always be, it'll be like a T. So wherever that electric field line is entering that material, 90 degrees to that will be level.
Yep. And that's the funny part, because mainstream science agrees with us across the board. Absolutely 100%. Nobody can dispute it, because their science tells them the same thing. Where the dispute comes from is the source of the electrostatic field. And that's, like I said, pretty easy to disprove. They disprove it themselves, with their Star Trek-like shields and all the other stuff. And we prove it, the existence of it there, by anecdotal evidence and, physical evidence. There's physical evidence. We can actually see things happening at that 62 mile, and we just have all kinds of little tidbits of evidence, which is a lot better than zero, which is what they have. Let's continue.
Will follow these field lines as well. In this demonstration, instead of using a flat plane, I use two circular objects as my Gaussian surfaces. You can see that as the water settles after being sloshed around by me turning the wheel on the Van de Graaff generator, it comes to rest with a curve in the surface following the electric field lines between the two spheres. This is why the ionosphere, a phenomenon that has never been created in a lab, is a theory yet to be verified, but is needed to create this phenomenon here on Earth. Maxwell himself changed Ampere's law, which stated plainly that without matter, no electrostatic field can exist.
Yeah, and that is important. Maxwell just out of nowhere, of course, Maxwell was, a glober. He was pushing this glober agenda. But Ampere was the guy that did these initial calculations on the electrostatic field in the first place. And like I said, guys, it even makes sense. If you don't have anything to apply a charge to, you're not going to have a charged field, right? Nothing there, nothing's going to get charged up. It's as simple as that. And we actually, now, Zack and I have really, done our homework on this. And there are several mainstream physicists and engineers that are saying, how the hell could he do this? How could he do this with no evidence whatsoever? Where did Maxwell get the balls to just change this theory to say, well, you can charge, nothingness, put a charge on nothingness? Again, this is just their stupidity. And there are a lot of physicists that are disputing it. Go ahead.
Walter Lewin, former MIT physics professor of 4 decades. He even says Maxwell changed the equation with no experimental backing whatsoever. But because of the way our Earth is and the way the universe is, it has to be. He says that.
Yeah, it has to be, because it has to match their model, which again is complete fantasy. And other than made up evidence, they got no evidence at all. And that's really the truth, people. It really is. Let's continue.
But wait, as a glober, don't you at least have to admit that you consistently have to invoke ambiguity, or I don't know if incredulity is really the word, but you have to constantly appeal to the idea that you simply don't know yet, but it has to be that way. But if it wasn't that way, we could explain everything. It's baffling.
Yeah, no, and I get you too. I mean, I totally get it, Austin. And that's the thing. We sit there and we watch these globers, the way they argue, and we've watched this argument evolve over the last 7 years, right? To the point now where they say that there is no geometric horizon, that they say straight equals curved, right? They're really saying this, guys. They're really, really saying this. And it's so pathetically absurd. It's unbelievable. And they say it with such conviction that they think they're going to get people to believe it. Well, true. If you say stuff with enough conviction, people will fall in line and believe it. And that's exactly what they're hoping for. But that's the whole thing. I mean, God, a good example of that is Ranty's newest video that he did on, well, I'll tell you guys about it later, but it's pretty funny. It's pretty funny. But the Globers, basically, they just make crap up and then they keep asserting it over and over and over again, and they will not back down from it at all. Even if they tell you that black is white or red is green, whatever, the obvious, they completely deny it. A straight line, no, that's curved. Is that your hand in front of your face? No, that's not your hand. That's That's an apparent position. Equatorial.
Job to be
I'm
a
sorry?
Glober troll. That's got to be the worst job in the world, to get paid to troll flat Earth. Those J-Trig guys.
Yeah, no doubt.
My goodness.
But wait, the
I see
crazy part
most
is
of
that they don't even know what the top tier of their side says, right? Like, this is another perfect example. Oh, all observable phenomena can be perfectly explained. Everything we observe on the Earth, bam, perfectly explained. But if we assume the Earth's a ball in space, then it doesn't adequately explain it. So we must change it, make up a fairy tale because it doesn't work. And no, we can't prove it, but it has to be that way, or what we assume is wrong. And we know that's not the case because it can't be. It's just, I don't know. I'm blown away. Like, I don't you see the people that come around and they say that horizontal doesn't mean flat, level means curved, and all this. Sea level isn't actually level, even though we have elevations. Like, those people, I don't even really consider those like real people, right? But like the top tier, they know what they're doing, right? Like, this person, Maxwell, knew what he was doing. Maxwell, if you've read any Maxwell, he was far from dumb. Not even close to the word dumb. He was not deluded enough to think that this was reality. Right? So it's like they're making a conscious decision to turn their head from observable phenomena that is explained and then leap over to the philosophical ground they prefer that cannot be explained. And they actually band-aid and replace all actual evidence with it. It's wild. And so, like, for the people that don't even know their side, of course they don't understand the magnitude of this situation. Right? But like, it's people like this. Like, I hold Maxwell accountable. You see what I'm saying? Like,
absolutely.
That's the real problem. Yeah.
Absolutely.
Because he's operating clearly with an agenda, just like Einstein was. Just like, fortunately, Newton was smart enough to say, no, don't you ascribe that bullshit to me. I'm sorry, we're not gonna go there with that. Don't put that to me because I don't see it operating that way. He saw gravity as a local field only, and he was right, because it is a local field only, and it only takes place in this realm. And the more we understand this, the more we're going to be able to test this. But electrically, we've already got the evidence that completely devastates it. So let's continue on and finish this video up.
Without matter, no electrostatic field can exist. Maxwell changed it with no scientific evidence, allowing it to gather magically above our heads in free space. Density and electric potential go hand in hand. The denser something is, the more electric potential it can hold. Not that I believe in the model of the atom, but even the periodic table has a distinction on the amount of electric potential there is in the different elements. In this demonstration, I have a metal button hanging from helium balloons that keep the button buoyant just above the ground. By only adding more electrostatic potential to the button, you can see it will appear heavier and force the buoyant object down along the vector lines created by the electrostatic potential difference. Without changing the density of the medium or the object, one can change the overall weight or gravitas of the object. To do an actual experiment on the topic of gravitation, this variable of electrostatic acceleration must be taken into account at all times. Now we will take a look at how different electric potentials of gases act in this electrostatic medium we live in. Gases have different electric potentials, just like all matter does. The gas molecules that can hold more potential than those gas molecules around them are theoretically more dense and will have a stronger attraction towards the negative ground below. When these gases are carried along the downward vector by these electrostatic forces, the lighter gas gets displaced and becomes buoyant until it finds a place with the same electrostatic potential. This is why we have a pressure density gradient and are told the noble gases work their way up into the higher elevations and collect in layers above. This has not been verified by anyone I know, so at this point I cannot say if this is true or not. Through this induction, some pretty amazing things happen when large electric potential differences are applied to gases. When gases are placed into an area with a strong electric potential difference, we get the phenomenon known as ionic wind. If a person were to charge themselves up with 1 million volts of static electricity, they could blow out a candle almost 2 feet away from the gases rushing away from their fingertip because of the exceptional potential difference. We do know that when a gas loses its electric potential, it slows down so much that it turns into a liquid, like the condensation that forms on a window when it's cold outside. The gases hit the cold window and transfer their potential energy to it, trying to mediate the temperature. In doing so, the gases lose their electric potential and turn into a liquid. Down here near the surface, the system is very dynamic, with all the plants and animals breathing, low altitude weather patterns constantly cycling, and Earth releasing gases from the deep at all times. We will never see all the gases lose their potential and turn into a liquid anytime soon, I hope. Now we will get to the incoherent part of the phrase. It is called incoherent because it is not completely polarized, like a magnet, but only slightly on its surface through electrostatic induction. A magnet with all of its potential stored on opposite sides would be considered coherent. Now these forces are very weak and only apply a slight pressure along the vector they create. All other pressure mediations, such as buoyancy, atmospheric pressure, and temperature, are certainly stronger, but nonetheless, these weak electrostatic forces are ever present in the world around us, and I fear the day they may come to an end. Again, I fully understand people's reluctancy to use the word gravity when speaking of this place we live. So instead, let's call it what it really is: incoherent electrostatic acceleration. Let's teach those just finding out the nature of this world in which we live the correct way. The fact that we live in an electric realm with a static electric field you yourself can go out and measure tells us without a doubt that these well-understood laws of electricity create the downward bias phenomena we witness all across the plane. Instead of using the word gravitation, I ask you to educate yourself further on incoherent electrostatic acceleration. This is Good Times for All here, signing out. As always, thanks for watching.
Very nice, Zach. Very nice. So there you have it, guys. So, what I want you to take away from this most of all is that even the mainstream acknowledges and models the idea that we are in some sort of a structure, whether they want to admit it or not, that allows for a linear equipotential voltage field, which carries on so many functions it's almost unimaginable within our realm. And it's amazing because all you have to do is apply this roof and the walls and the stuff to the biblical description, and even the way that the book of not Ezekiel, Enoch. Even the way the book of Enoch talks about the propagation of the sun. And that's something that we're probably going to cover in our next lesson next week. But we're going to look at this and we're going to start fitting the pieces in where they belong. And we're going to use as much of the mainstream physics as we can to prove it. And of course, we will fill in the gaps with more logical and more testable science as we go along. So that's kind of what I wanted to get across to everybody today, and I hope I did. So what do you guys think? You have any questions on this?
It's a really, really hard topic for me to digest. I'm going to see a few times because it's very interested. and interesting. I never can pronounce well, but it has a lot of logic, and I have the intuition of all this information. Sometimes it's difficult to put on paper or number or trying to explain. The work that Zack did is amazing. I'm still trying to share with the Spanish community. I always open these 2 videos that you show, but I think sometimes when you start entering to studying the flat Earth, of course, the gravity is one of the main topic to trying to educate yourself, and as soon as you start looking in other options, the electrostatics and the electromagnetic fields and things like that is something that came like by intuition, if you want to see it in that way. Of course, my question will be what happened with all these experiments in very lower temperatures, because for me, at least we must have that in consideration. Maybe it worked better, or
Oh, I agree. In fact, I think the sub-zero or the absolute zero experiments are going to really reveal a lot of amazing data. Yeah, absolutely. And a lot of things that you said when you presented that at the, I'm sorry, go ahead, Zack, or whoever.
We create those superconductors that or what are they called? Where you can just stick it above a magnetic wheel in the air at any
superconductivity, superfluidity. We have those phenomena that supposedly it was discovered in the early 20th century, but with that Abra Space agency that sent that sounding rocket and showed that type of temperature, and for me it was a really at least something to consider, that if you start cooling down things like gases, you're going to have this crystallization effect. So you can have, like a container without evoking, some magical things like molten glass or things like that. And the other thing is, it's really difficult to make experiments at lower temperature. We don't have that capabilities in our garage. It's not easy to do those kind of things, but for me it's a very key, because after all we need to explain, and that fits perfectly with the no friction effects in this celestial body, because after all we're trying to describe what will be possible happening in terms of the dynamic, the forces, but we have that element that there is no friction, or at least never change its velocities or periods, or whatever. So the lower temperature will be something that, if we have someday the possibility to experiment, will be really great. But the topic that you cover is amazing. That is why I want to see a few more times.
Okay, well, we have a lot more on this, and I do mean a lot. During the time that we took over the break, Zack and I, we did a lot of talking, we did a lot of research, and we found a lot of things. And it's amazing because, like I've always said to people, when you are earnestly seeking something, you will find it. You will find it. It's just the way the universe works. I don't know how, I don't know why, but I do know that it's the truth. And some of the stuff that we came upon was just amazing. And I think that we've already defeated the globe model in so many ways. It's ridiculous. I mean, when you have people telling you that there's no geometric horizon or that straight is curved and shit like that, they've lost. It's over. Say goodnight. Don't even talk to them anymore, right? Because they've sunk to the ultimate in gibberish. And, it's time to pick up the pieces and educate ourselves. And while we don't have all the money in the world to be able to do this, I don't necessarily think that it requires a lot of money to do it either. I think that, most of these research grants that people get are so bloated that they have to keep large mega corporations alive, that they have to make, a toilet flushing experiment cost $10 million. It's absurd, but, and I'm being facetious, obviously, but that really is the way that it is. And this is a time in our history where... go ahead, Zach.
Bob. Last year, they gave $2 million to research how dung beetles have sex in this country.
Yeah.
Yep.
Yeah.
It's like really, there's so much more pressing matters that could be focused on right now than how dung beetles have sex. I'm sorry.
Yeah, that's just disgusting. I'm sorry.
But $2 million, it's crazy. That's just insane. How much are they wanting to figure out? I mean, really?
Yep.
I don't know.
That's true.
But yeah, the money needs to be allocated totally differently. I mean, well, yeah, once the truth comes out, I think we're going to see some amazing things happen in this place. Like you said, it's getting better, Bob. There's that light on the horizon, I'm thinking.
Yep, I agree. So one of the things I want to show you guys while we have this up, there are a couple little highlights. It's already 5:20 here, so I think I'll probably just keep both shows open, the Rokfin and the YouTube, because I ran way over. But it was really important to me that we get that foundation in on the electrical nature of our Earth, and the fact that we have mainstream backing on 90% of what we're saying is astounding. And it's so easy to debunk their nonsense of first they're telling you, well, there's no way that you can have that without these massive incoming giga electron volts energies coming in. But unfortunately, good thing for us, our Star Trek like shield in space blocks all that out. And on and on and on. I mean, I'm just referring to those as two incidents, but it goes way deeper than that. But this week, and we talked about this a couple weeks ago, and Eero actually found this a long time ago.
I'm going to buy you one of those some days, Bob.
Oh God, I wish.
I promise.
I wish, Eero. But this watch is, what is it, like $450,000 or something like that?
Yeah, you have a wide gradient of prices, but never less than $200,000.
Yep. But the thing about it,
200,000.
The thing about this watch that really caught my eye, I shouldn't say my eye, I should say Cami's eye, is Cami has had in her mind what the ideal map would look like, and this is it. This is the map that she says is the correct one as far as perspective and all of that stuff. And isn't it interesting? It comes on nearly $500,000 watch. Absolutely insane. But it's just interesting. So it's called the Beauvais Grand Recital.
Name is very suggestive. Yeah, the name, the Bobet is like saying the bóveda in Spanish. How you say in English? Bolt, I think it's
okay.
The semisphere shape. How you call that?
Oh, like oblate spheroid?
No, not exactly. Let me just I'm going to find the word, but it's referring to the celestial semisphere in the sky. Sorry,
okay,
guys, but
no
I left the word, but cupola. Cupola. It's mean very quickly. I have here the translate. Couplet. No, sorry. Cupola.
Cupola, like on the
dome,
like on the
dome,
ISS.
Dome, like a dome.
Like a dome. Okay.
Like a dome.
Bovet is like saying dome.
All right.
Okay.
So anyway, and it's kind of hard to find the exact good picture of this. There are a few of them that are a little better, that you can actually magnify it. But this is the map that Cami feels is absolutely the correct one, perspective-wise. And so there you have it. We're going to try and find some better pictures of it. And apparently there's a knockoff that you can buy for $400 or $500, something like that, which would be kind of cool actually to have something like that, because this looks like an extraordinary watch, and it tracks everything perfectly. Just like you would expect from a $500,000 watch. Pretty crazy. All right,
Yeah.
and
if you know, when I research about that clock, it was because I'm trying to follow the route of the Antikythera. I don't know how you pronounce in English.
Antikythera.
Yeah, the Antikythera mechanism.
Mhm.
And I don't know why, but following some links, it took me there to this company that, and the guy who is the CEO of this company, it has a few interviews on YouTube, and it's very, at least when you start, hearing what he said, he knows something about our world, because I cannot remember exactly what he said, but he started talking about cosmology and who we are in the world and what is the motivation behind of created that type of clock, blah, 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 blah. But it's someone that belong, of course, to hierarchy bloodlines. It's like maybe his grandfather was a Templar in the old Crusades and bring some knowledge from that lands.
Okay. Awesome. All right.
Ira, hold on. I think I actually unmuted. I am so sorry about earlier. I took the dogs out and I'm not sure what you got. But Ira, this is a new watch. It's the brand new one in the line. And they've actually even cleaned it up further and made it really match the Antikythera and have cleaned up the lines. It's actually a flat map underneath a dome. And the last watch was really good. This one took it all of the way. It puts all of your phases in not only correct position, but correct phase and angle in that. This is pretty much your watch version of the Antikythera. And this particular, the grand recital was at $579,000. But we were able to find a replica that I'm thinking about ordering. And this is kind of funny when you think about you're ordering a knockoff watch. We found a Miss Carolyn found one, and I believe it was right under $400, which might be doable. But you're thinking, oh, I'm going to get a knockoff watch for under $400 and think of, what you think a watch costs. But it is beautiful in its perfection. And you're right, whoever did this knows a lot. Take a good look at where Greenland is on the map. I think that's really important when you look at, and I will jump back up, but I think when we go over and we were talking about where our auroras were and where they centered and how, again, it made no sense on the circling, and this all of a sudden starts putting a lot more of the pieces right into the puzzle. So a lot of things are corrected. They did beautiful on this. My favorite by far.
Well, I have here, if you don't mind, Bob, I can share very quickly my screen. I don't know if you allow me.
Absolutely.
Because here I have, again, I cannot remember exactly what he's going to say, but let me know if I am presenting right now.
Hang on just a sec. And you are presenting.
You are presenting. That is the recital 18. We are now up to the recital 22.
Exactly. Yeah. This is an old video, but this is one of the CEO at that time. Let me know. Let me reshare because I forgot to share the sound, and I do it again. Okay. It's not a long video. So I'm going to play the first one,
and
two minutes.
Before you start it, Jeran, if I'm not back when he finishes, just pick up the show for a minute. I got to go take a break real quick.
Sounds good.
All right, I'll be right back. Go ahead, Hero.
Okay.
I'll allow it, Hero. I wasn't going to allow it, but I'll go ahead.
Okay. Of course, if we are talking about watches and clocks, Switzerland, it's the country that have the big title in the arena of creating the one of the big most important watches. And by the way, this is the country of the Templars and some other elite guys. So it has something related. That for sure.
One of the most spectacular, if not the most spectacular timepiece that we've seen so far in 2016. This is the Recital 18 Shooting Star by Beauvais. Let's go and find out more about this incredible watch.
In 2006, when I took over the facility, Dimier, Manufacture de Horlogerie Artisanale, we were expecting, with all the artisans, to pay tribute to their unbelievable skills for the 10th anniversary of the facility.
Hello, and today we're going to talk about
Sorry
one
for
of the
that.
most spectacular.
Let me go again.
Unbelievable skills for the 10th anniversary of the facility. Since nearly 10 years, we are trying to express time in a different manner, by the same time defending unbelievable technical skills, but by the same time dressing the timepiece in a way which can surprise nearby the unbelievable Amadeus system. That idea brought to us another one. I'm very keen on antiques, even though the Shooting Star is a very modern and surprising timepiece. And came to me that idea that our ancestors were writing on writing desks. Thus, for the aesthetical part, and as far as we have such density and substance of decorative arts in all our timepieces, as you know, the case came exactly in the shape of a writing desk. To do differently is not difficult, but to do differently with substance, with soul, without betraying tradition, values, and the passion that our artisans are putting in our timepieces, this was one of the main challenges we wanted to face. In order to write the time on the writing desk, what kind of technical features we had to achieve? A jumping hour with a retrograde minute? Yes, I love the window of our jumping hours, so huge, and I do need glasses to read. But when I look at my timepiece, I can read the time without any glasses. The retrograde minute is such a pure pleasure. When you see it flying smoothly to go from 60 to 0 is a pure, again, it's a pure pleasure. Watchmaking art has to be emotion, pleasure, and thus that jumping hour is truly unique. With our tourbillon and its 5 days power reserve, we wanted to talk about travel, journeys, stories to tell around that globe. And came the idea to...
I love when he said around the globe. But, well, this is the you know, I you know, trying to bring history and, you know, our ancestors writing time on this and things like that. And of course, here you have the Antikythera mechanism, which is a really, you know, piece of history, because the people that, you know, supposedly this belonged to Archimedes, supposedly, right. You know, which is very, you know, strange. No, me either. But you know, the official story is that a Roman soldier killed Archimedes, and they took a lot of things from his house. And when they are getting back to, you know, Greece or Italy, whatever, the boat sank, and you know, all the treasures went down into the ocean. And 2,000 years later, we found that the real thing is that. Yeah, we found that, but all the mechanism itself, it based on the flat Earth, in the flat disk, and it could be, you know, considered one of the first computers, quote unquote, because it predicts 100 years eclipses and things like that. And
only the globe predicts eclipses, Iro. Only on a ball.
Well,
yes.
We can discuss that. Yeah, we can discuss that. That you know, this is like some type of bobette in the early times. And yeah, you know, I am not going to keep talking, but the bottom line...
history always have to be such nonsense, though. The one, my favorite one is the Library of Alexandria that burned for 6 months. It doesn't even make any sense. It's the dumbest thing I've ever heard. What do you mean?
What a fish story.
People don't know how to put out fires?
They're
or what?
buying it.
Why wouldn't you go get all the books that aren't on fire yet and move them?
Mm-hmm.
Not just leave them like, I guess I got burned now. Somebody lit a match and throw it on that book. What are we going to do? We're going to stay here for 6 months. Watch these books burn.
Look how many suspicious fires there were throughout history, like even in North America, right? That wasn't happening. There was something clearly else going on there. What it is, not sure, but
well, and why would we believe anyway that everybody brought all the books in the world to one library location? It's just dumb.
It's
yeah,
insane,
that's
yeah.
dumb.
No, and especially at that time, how many, I don't know how many papers, because people, imagine that 2,000 years ago, it was very easy to take a pencil and start writing down on paper, but
Right.
that is not the case.
No.
So what type of books they have,
Right. They talked about how big it was. I forgot. I checked one. It was like 4 football fields or something. It's just ridiculous. Like that would burn for 6 months. But even that, like you said, there's all these books there. The one thing you'd have to worry about would be fire, right? Be the only thing you'd worry about. So the people who built it would have fire breaks in it where it wouldn't cross. I mean, it's just such a dumb belief that like humanity's so smart. We got all our books together and put it in the great library and then it burned down for 6 months.
which is impossible, like we said before. Nobody's going to share books in one place.
They didn't rain for 6 months?
What?
I guess it didn't rain for 6 months.
No, well, it rained. I get maybe it rained and it just avoided the fire. The fire was that strong, so strong it just lasted.
But if you compare at least with the history behind London, England, when they, for real, they burned the city, and then they create the how you say in English, the sea of the law of the sea, the maritime law. Yeah.
Maritime law.
Yeah, they created that after they burned London. And they start saying, okay, if nobody came after 7 years, everything is, belong to us. And, they love to burn things for real or for made up stories.
Yeah, it's so easy. I mean, if you're in charge of what books go out and you're in charge of history, we should know that everything that's told to us is for a reason. There's a agenda behind it.
Yeah, and
real history. We put all the information in the world in one location and let it burn for 6 months. I'm sorry, so that's why you don't.
But getting back to finish this topic, this is a really compiling images in terms of that. After all, our sky is a perfect clock, and you can, transfer that to a mechanism, a flat mechanism, a geocentric mechanism, and read our sky. that's it's the bottom line for me. We are under a giant clock in some way.
Without a doubt, absolutely. Yeah, and it's funny that they stick that in front of our face, by that very mechanism, by a clock that's $500,000. So yeah. So anyway, all right.
Looking for information on the sky, like I used to go to the U.S. Naval Observatory, but now all of their charts, I mean, they have a button you can click, but I've clicked it like 10 times and it always ends up to, you ran out of time, check your internet connection, blah, 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 blah.
Really?
And that's the only site it happens on. Yeah. Whenever you go to try to check the moon or sun azimuth altitude charts, they don't supply them anymore. That was my favorite place, but I found one called heavensabove.com. And it works really well. It takes a little bit of time to navigate through it, but you can get really good, accurate data on like on this upcoming test me and Lucas are going to do. It's really good for finding, the perfect midnight where the moon is exactly your highest point in the sky. And, or solar noon where the sun is the highest point in the sky and things like that.
Zach, do any of those websites have the actual visuals of like what the moon position and would actually look like? How much it's wagon wheeled or anything?
Even Royal Observatory will not show you that. Chris asked for that raw data, and the guy told him he could not give it to him.
That's suspicious, don't you think?
Because he specifically asked him about that, and the guy confirmed it. He's like, yes, it does wagon wheel from here, at this latitude, yada, yada, yada. It does it this much. And Chris wanted to see those pictures raw without them straightening them out. And he said, no, that's not possible.
Yeah. Well, one of the other things that we're going to be covering as we go through this kind of, remaking of our model is showing that these stars out there, there's so many proofs that they are not billions and millions of light years away. And in fact, the stars appear to be roughly all at the same altitude above and away from us. And how do we tell that? Well, we can tell that by the parallax that is not there when you do time lapses, right? And there's several other ways to look at this also, but Chris Van Maitre did a great video on it. When you got the moon that is exhibiting the same amount of travel in the sky as you do the stars behind it, Houston, we got a problem, right? That is not possible when you have something that's allegedly only at 238,000 miles versus God knows how many light years. It's just not possible. And that's just another one of those things we're going to be looking at, because I'm sick and tired of this stupid BS heliocentric model. It's bullshit from top to bottom. None of it makes any sense.
It's them laughing at flat earthers and they make fun of it like it's this big joke when their model is a much larger joke. It's totally an enormous joke. We're flying around I heard a guy on this podcast the other day talking about, flat earthers think that the disk is rising. They think it's rising in space. It's like, you think we're flying in space 2.1 million miles per hour. So even if flat earthers did believe that we were rising, that's a lot less motion than you believe.
And flat earthers don't believe that. They tried to saddle that onto the Flat Earth Society. And who actually came up with that theory? None other than Albert Einstein. And not only that, guys, but they still push that today as that is actually what is happening with the Earth. They're trying to tell us that now.
The equivocation principle, like effectively the Earth is accelerating upwards.
Yeah, it's like, get real. But yeah, first they said it was absurd for the flat earthers to claim it, and they blamed the Flat Earth Society for that. And in fact, it was Einstein, and the fact that they still do. And it was that one, same one. I think it was the Sunday Mass Show again, where I cracked that out, where the Gabe Giz or Giz or whatever his name is. And he's talking about this theoretical discussion between Newton and Einstein and how ultimately Einstein wins it. But he says the only condition is that the Earth would have to be on a flat construct, and then it all works. It's like, oh, really? So it was really Einstein that came up with this. So what do? They ridicule it and say that flat earthers claim this. Unbelievable. I mean, just unbelievable. That's as dumb as claiming that a flat earther proved the rotation of the Earth. So anyway, all right. So let's get to the last couple of things, and we'll call it a show because it's a quarter till here. And you're going to love this one, Jeran. Physicists cracked unsolvable three-body problem using the drunkard's walk. Oh. Now, this is going to be good already, right?
It's the same exact title in Spanish. So they are not even care about using same phrases and No, it's insane. It's insane.
It is. So let's read a little bit.
Read it, please.
A physics problem that has plagued science since the days of Isaac Newton is closer to being solved, say a pair of Israeli researchers. The duo used the drunkard's walk to calculate the outcome of a cosmic dance between three massive objects, or the so-called three-body problem. For physicists, predicting the motion of two massive objects like a pair of stars is a piece of cake. But when a third object enters the picture, the problem becomes unsolvable. That's because when two massive objects get close to each other, their gravitational attraction influences the paths they take in a way that can be described by a simple mathematical formula. But adding a third object isn't so simple. Now, the first thing you have to think about this, right, is, what harkens back to me is the Glober saying, oh yeah, well, how come your flat earth model, you can't predict any eclipses? Well, doesn't the eclipse require interaction between three bodies? And you can't solve that. So where in the world is it actually coming from if you can't even solve that? Good question, right? Anyway, but adding a third object, sorry, I read that one. Suddenly the action between the three objects become chaotic. Instead of following a predictable path defined by a mathematical formula, the behavior of the three objects becomes sensitive to what scientists call initial conditions. That is, whatever speed and position they were in previously. I don't understand that, but whatever they were in previously? Okay, well, whatever. Any slight difference in those initial conditions changes their future behavior drastically. And because there's always some uncertainty in what we know about those conditions, their behavior is impossible to calculate far out into the future. And it goes blah, 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 blah. So basically, they headline this that they've got it cracked, right? But by the end of it, they tell you that they don't have crap cracked. They don't have anything cracked. They didn't solve anything. They're talking about a drunkard's walk, but they do this so many times, guys, in so many articles. Oh yeah, we solved this, but no, we really didn't solve it. But this gives us good guess on it. But why did they even say that they solved it, right? And then back out of it.
No one will ever read it. It's literally explaining how they could never solve it. Not only are they claiming to even solve it or work towards it, they're saying you could never solve it, but they just know someone will just read the article and be like, "Oh, okay, cool."
Yeah, it's a big step.
But if you go to the I don't know if it's the same as in Spanish, but if you go to the the end of the article, they say basically that okay, we're going to solve doing like never happened. I don't know if I
think that's the end of it. Let me see. Yeah, that is the end of it. So at the end of it, it says,
okay.
This is a big step forward for the three-body problem, but Gannett says it's certainly not the end. The researchers now hope to figure out what happens when the three bodies are in special configurations. For example, all three on a flat plane. Another challenge is to see if they can generalize these ideas to four bodies. So they still can't do three.
Why don't they call Res Rhetoric? He can do a 75 body problem right now.
In his head. I know.
In his head.
In his head. He told us so.
He can do all the moons of Saturn at one time. He'll do it right now.
That's epic, Jeran.
Very funny. Very funny.
That guy looked like such an idiot on that one. That was great. I'm surprised he didn't care. I mean,
I'm surprised he's still breathing.
They're done. I think they hung it up.
God, I hope so.
Yeah. Implicated in some sort of scandal some sort of donation scandal. I'm not like them. I don't just make blanket statements like, Bob, how many times have you heard that you bought a $20,000 ring laser gyro?
A million.
Oh, in Spanish community, they
you guys can get all the money you want for anything, man. You guys got $20,000. It's like, no, one guy that has money bought that. Has nothing. It's not. We didn't fundraise for it. We didn't do a GoFundMe.
Yeah, and that's the other thing they say. We fundraised for it. We did a GoFundMe for it. It's like, no.
Right.
Rick paid right out of his own pocket, cash money, bought it himself, and of course he did the experiment. I was simply reporting on it. And I'll take that rap. Yeah, I reported exactly what he said. I wasn't going to lie about it because I'm not interested in lying about it. But the point is that we figured out what actually was going on there. But now that the truth is out, they don't want any part of it. So what else is new, right?
Not much thanks, Bob, anymore, huh?
Yeah.
Well, okay, so I was on one of my shows and I showed that Antarctica 24-hour sun video and showed how the clouds matched up. I don't know if and then I had a whole bunch of people calling me a liar saying that it didn't and that I was showing the beginning of it. So I showed it again on my show, but I can show it now if you want.
Sure.
Just to finish, I know we're.
Yeah, I know. I did see what you're talking about while you're queuing that up.
And you thought the same thing, right? I mean, it's pretty obvious.
It's freaking blatantly obvious.
Okay, good. Making sure.
It is so obvious, but
I think
also
there's just people that are hired to go out and just. It has to be that just to no matter what you say, they're going to say nope, that's not true. Just because then you're like doubling back. It's not. You can't just say something and move forward. It's always say something. A bunch of people cry and complain. Now you got to go back and explain yourself, and then it's like part of the plan to kind of hold you back.
Yeah,
I think.
I agree.
Because it's all it does.
Yep.
It's usually what it does. Where's my share screen button here?
Okay, just let me know when you're sharing. In the meantime, we are watching just a quick hat tip to That Flat Fellow, who made an excellent compilation of videos he calls the Flat Earth Kid Show, and it's really good. It's really good. It's really cute. I won't play any of it except what we're doing here, but you guys need to go out and check it out because he did an outstanding job on it. God, it's an hour long. I can't believe that. But all these little different skits, and it's amazing.
Oh, great. That's the one that Karen and Brian played the other night. Oh, it's fantastic.
I don't know if they played it or not, but he played it last night or the night before, one of the two. I think it was last night he played
It's got
it.
like raps. It's got a little raps and like little characters from.
Still see the Orion's belt. In fact,
Yeah, stuff like
you can
this.
see it every single.
Yeah, there's rappers and.
Yeah, Brian played it.
World is flat. Like a cookie, it's flat.
But yeah, it's really good, guys. Check it out. I'll put it in the show notes. It's just outstanding. Great effort by that flat fellow. Thank you, sir. It's excellent. And I'm ready. Whenever you're ready, Jeran, I will share your screen.
Yes, 1 second. I'm trying to make sure that this is going to work when I screenshot this. Okay, we're good there. Nope. All right, and I'm going to save. Oops. And then screen share. And tell me, it looks in this screen, it looks distorted. Is this video distorted or is it fine?
It looks okay to me.
Okay. So in this video, I was just pointing out to people that this guy comes out and says, it's summer.
I don't hear any sound.
Oh, I didn't share with sound. Sorry, let me do it one more time.
Oops. Different systems.
There we go. Start sharing. Okay. Oops. Confirm. Stop sharing. Okay, pick the right one. And sound.
I can teach you if you want.
Thank you. I'll get lessons after this. And so he comes out and says it's 12 o'clock after midnight.
It's the middle of summer. Check the time. It's just after 12 o'clock.
That's hard to fake. That's hard to fake.
Yeah. And here's the problem already is that you would think then that this is where the camera's going to start panning, right? Because he just came and spoke to the camera. Why would at this point would you move the camera? And they do. So you'll notice here. Oh, by the way, notice here how high up the sun is. Notice that we've got this kind of double peak mountain here, and how far to the right of that the sun is, and then you can see this little mountain starting here. Because the next scene is where the thing starts. You'll notice they move the camera. Okay, so the camera is in a completely different spot because if you look at this building here with two windows and kind of looking right along this big peak here, you go back here, you'll notice that he moves.
Well, not only that, there's also a ton of snow on the mountain. And you have an echo on you, Jeran. I don't know why. I hear myself and I hear you.
An echo?
Yeah. I hear you.
I cut off.
Okay, I'm going to take off the sound now because I don't need it anymore.
Okay.
Because I believe it only was me, but no.
No, I was hearing it too. It was weird. That's okay. We'll get to it here.
Okay, we don't need the sound, so it's back now. Now there's no echo, right?
Exactly.
Nope, no echo.
Okay, so
can you maximize that?
I'm on my. Is that okay there?
Yeah, that's fine. It didn't really change things, but it looks good.
Yeah, let me actually put it on my other monitor. That's the problem, is that I'm on my side monitor, which is turned.
The aspect ratio screws it up. Yep.
Yeah. So let me move it over here and reshare. That'll be better for everybody. Okay. Skype, this one, and stop sharing. Confirm. Share screen. All right. Now we're on the big one. Okay. Start share. Get out of the way. All right. So now you can see it. Yes.
There we go. Now we got it.
Okay. So you'll notice that those two windows that we're looking at are here. And remember this mountain. So they kind of move the camera down here somewhere. So anyway, it's just weird that why would he come over and pull it's 12 o'clock and we're going to do that? Just seems fake to me. But as I was watching this thing start taking off, and we're going to come here, I'll show you where we're going to pause it. And this is where people are like, no, wait, you made that up. So watch these clouds coming. Okay, I'm just going to stop it there. And you'll notice that we get this little duck mouth here, this little thing. So I'm going to take a screenshot of that. Hopefully my screenshot tool works here.
Didn't David do this also?
He did it for that one that there was like shadows or something. Remember that one?
Yeah, I do. But I mean, I've definitely seen this one before too. And there's absolutely no doubt these are the same at the beginning and the end. They're identical.
Identical.
Yes, completely identical.
I'm going to try and do a screenshot here. It didn't take it from the full screen. Okay, there. I guess it goes to the clipboard then maybe. Okay, so yeah, then we're going to go forward. And remember, we had that little duckbill thing there. Oh, one more thing. So remember here, the sun is way high in the sky over here where these two peak mountain is. Now when we come around further, okay, here. Now this is that two peak mountain, and this is the mountain. So the sun should be here-ish, right? I can see it being a little lower, maybe here-ish. But look where the sun is when it gets in. How could it be that low? The sun in the other view was way up here. So just to me, there's no way. When we were looking before it, double peak mountain, then there was that little mountain peering, and then the sun was up high. Not, if we just rewind it a little bit, that sun is going to be dipping down here-ish. Go here. And the sun's like here, like almost behind that mountain. So it doesn't seem right there. And then this is the big part. How could the clouds ever be identical to what they were the day prior? So here comes the sun. And if we pause it correctly, we're going to see the exact same, a little bit too far. Usually I slow it down. But you can get to the exact same, too far, exact same positioning. There it is, kind of. There's the little duck mouth, and you can pull these clouds, it's identical. Let me see if that actually saved to my clipboard. I don't know where that goes. Let me check over here. It'd be in pictures. Let me try this. Do I have screenshots over here? Screen grabs. Nope. I wonder why it's not.
You know, it's weird. I'm almost certain that Dave did this one, and he said something about, oh, the guy must have had to go take an emergency poop or something, because he came back and this was all covered in snow, whereas at the beginning it's not.
Oh, you mean when the guy's up on the top of the hill?
Yeah.
Yeah, at that point it's not. Huh? I mean, there's no snow up there. So I don't know why they do that. I mean, it's like if they wanted to fake it, it would be so easy to fake, and yet they always like leave it so that you can figure out that it's fake.
Yeah, well, I'm going to show you something, guys, in a minute. That's you're going to rethink all of that.
So let me see. I saved this view right here of this little duck mouth. I'm just going to pull it back here to the beginning, and we're going to see if we get the same one right about there. Okay, so about there. And then if I grab the other screenshot desktop, where is it? And I think the problem is I have to move it over to this one, or else it's not going to.
Yeah, I don't see David in the chat. Where are you, David? Mr. Rat.
Dave, where are you?
That's, I don't know.
Grab.
We'll find out.
Yeah, I know.
We're just screen grabs.
Somebody,
I
oh, you did this one already, Jeran. I could have swore you guys covered this and showed it.
We did.
I showed it on the Friday show last week. But I was just covering it again because people are still, it's in the Telegram groups where I'm like, all right, people knock it off. I don't know where my little screen grab thing keeps putting things. It's like automatically saving them somewhere, and it's not saving them where I would want them. So anyway, you can do it on your own. Just take a screen grab of this, and you can, especially if you slow down the timer, you can match it up to where the clouds are perfect. So to me, what are they doing where if you really wanted to prove the 24-hour sun, then you would just film a 24-hour time lapse, and there would be no possible chance that the clouds matched day 1 to day 2. There'd be no chance that you'd be having the sun in the wrong position. And like you said, so at the beginning, if there's no snow on this mountain, and then they decide to take now there's snow. So why is he pretending like, oh, it's 12 o'clock midnight right now? And maybe for all we know, that's why the sun is off, right?
Yeah,
okay, so the sun,
this is absolutely it, Jeran. David did cover this. He made a video on it, and it's positively where he said, "What? Wait, where did the snow come from? Maybe he had to go take an emergency poop that took forever, right? Because all that snow came up."
3 months. So it just doesn't make any sense to me. Why would you parade this guy out there and he's got a little cocky attitude, like he's cool because he's down there? Like, look at. Oh, is it?
Yeah, can't fake that.
Midnight.
I believe it's a Bobette. Is a Bobette clock that.
Yeah, that's it.
Yeah, I said.
Oh boy. So anyway, I mean, just things like that tend to. I mean, you don't need to lie to get the truth across. You don't need.
They've now come up with a solution for their lie.
What is it now?
You guys ready for this? You got to unshare your screen. I'm going to take the screen share back.
Okay. I can find this one, I think. There we go. I think you have it back.
I do. All right. So let me go share screen. I believe that's our Huckleberry. It is. Okay. So a friend of mine actually sent me this, and I just thought that's kind of interesting. It came across on TikTok. So I'm going to play this for you, and then I'm going to, then interestingly enough, the fact checkers picked up on it. And so I'm going to let you see what you think of this. You ready for that? So let's give this a listen. Here we go.
They love me.
Into their sky? Look at this. Tell me why China is launching an artificial sun into their sky? Look at this video. This is their artificial sun launching into the sky. Look. Hundreds of people filming it. I'm gonna tell you what this is. Look. Why? What are they doing? Look at that. Launching an artificial sun, really? One sun ain't good enough? Basically what this is an artificial sun that is 5 times hotter than the real thing. Basically the researchers hope that this could provide almost limitless clean energy. It does this by mimicking the natural reactions occurring within stars. This costed $700 billion. They will run this experiment until June. This is crazy, man. Tell me why China is launching an artificial sun?
Let me stop it. All right, so I looked at that and I thought that's interesting. So I did a little cross-checking on it. And it's always interesting to see what the fact checkers say about it, because usually the fact checkers will most obviously have the most ridiculous explanation for it. And true to form, yeah.
Honey, you have the Beauvais back on the screen. You're not showing.
Oh crap! I'm sorry.
It was on the presentation.
I'm sorry, guys. Okay, let me go ahead and play it again then, really quick. Sorry, guys. Here you go. I am sharing left now for everybody. Yeah, just the panel slot. Let's play this one more time.
Into their sky? Look at this video. This is their artificial sun launching into the sky. Look. Hundreds of people filming it. I'm gonna tell you what this is. Look. Why? What are they doing? Look at that. Launching an artificial sun, really? One sun ain't good enough? Basically what this is an artificial sun that is 5 times hotter than the real thing. Basically the researchers hope that this could provide almost limitless clean energy. It does this by mimicking the natural reactions occurring within stars. This costed $700 billion. They will run this experiment until June. This is crazy, man. Tell me why China is launching an artificial sun?
Okay, so now that definitely went out. Okay, so I did a little fact checking and went across this fact check on it. And it's so stupid, it's laughable, but listen to what they say about this. Let me back this to the beginning, and here we go.
This video is being shared on social media platforms with the claim that it shows China's launch of an artificial sun into the sky. According to news reports, recent experiments revealed that the Experimental Advanced Superconducting Tokamak, or EAST, nuclear fusion reactor, also known as artificial sun, delivered a temperature of 158 million degrees Fahrenheit or 70 million degrees Celsius for 1056 seconds, approximately 18 minutes. This is higher than the temperature normally provided by the sun. A researcher at the Institute of Plasma Physics of the Chinese Academy of Sciences who is in charge of the experiment said, "The ultimate goal of EAST is to create nuclear fusion like the sun using deuterium abound in the sea to provide a steady stream of clean energy." However, this was conducted in a controlled environment and China did not launch the artificial sun or the reactor into orbit. This news of nuclear reactor attaining high temperature has
But nobody said they launched it into orbit.
Been misconstrued as China launching an artificial sun. As for the video in the post, an internet search with the relevant keywords revealed that China recently launched the Long March 7A rocket that carried 2 satellites into orbit from the Wenchang Rocket Laboratory. Visuals of the launch are available online. In this video, we can observe the outline of the exhaust gases released in the form of a huge white cloud as the rocket ascends, resembling the visuals in the viral video. An internet search yielded a few news articles that published images of a beach close to the rocket launch station from which the launch could be viewed. The location in these photos resembles the location in the viral video. Although we could not independently verify that the viral video shows the recent March 7A rocket launch in China, we have enough evidence to conclude that the viral video does not show China's launch of the artificial sun, making this post fake.
When you come across a
Okay, so what does that mean? Is it real? Is it fake? We already know that they have artificial sun patents. We've all seen the Google patents. The United States has them. China has them. They've been talking about putting them up. And I think, Jeran, you and I have talked several times. It's like, yeah, they need to get one of those bad boys down there in Antarctica before the whole Antarctic scam falls apart, right? Because if they can put one of those up there in Antarctica, an artificial sun, then they can show a 24-hour sun, right? So I don't know. I just thought it was interesting, and their debunk of
we
it.
covered.
Yeah. Bob, can I chime in on this?
Sure, go ahead, David.
So I looked at that video. I put it in my editor. I'm looking at it. It's another one of those. Hey, look, everyone's filming this. It's not a real video, in my opinion. The people that are holding their phones up, they're not. Some of them aren't even looking in the right direction. They're not holding their phones in the right direction. It's only the two phones right closest to the camera that kind of look like, oh, they are filming something. And I just think they had something on their screens. The other thing is, look at all of those people filming. It's been out for weeks now, and no other video has shown up. I mean, if that one video went viral, where are all of the other 100 people filming? There's no videos anywhere. In my opinion, this is 100% fake with a fake launch, fake smoke, fake lights, fake everything, just to get people, talking about nonsense.
When I start looking into it, because we talk about this in the Spanish community, I have the same feeling as David, but with the difference that for me it's just a rocket launch, erasing the rocket and leaving just the thruster. Of course,
that's what I'm saying. I'm saying the same thing.
Yeah, because it's very easy in our days to just patch an image with, you take the. I am not going to explain very detailedly, but you take the next frame and you copy the sky in this case and you put as a patch, and you can very easily, in the automatic way, erase the rocket and leave only the glowing, thruster. But the other thing is that if that it will be a sun, at least you expect to create another shadow or things like that. And the real thing is that China, as equal here in Europe, they are creating what they call a second sun, but it's all based on trying to get more energy, and then in the free and more efficient way. We have I think the equivalent in Europe is called ITER.
Mm-hmm. So
that is the name of the sun, quote unquote, that they are creating here in Europe, but it's the same thing as China. It doesn't have anything to do with putting in orbit or sending into the sky, nothing like that. That is completely fake.
No, they say they do it. They just use a magnetic field that holds the plasma in at the center point to allow the temperatures to get very high. And then the magnetic field has such a radius or width, we'll say, that it keeps the plasma far enough away from the edges to where that it can maintain that temperature difference. So it's just it's literally magnetism holding plasma in the middle. It is what they claim they're doing now. Like, as to the validity of this or anything, I have no idea. But I find it interesting, as we know that we've been lied to about what the sun really is.
Yeah. So
it's
speculation,
like
David. We all
star in a jar.
Yeah, star in a jar. Well, that's interesting in itself too. But it's interesting because I thought, well, the patents have been there, and so they're like telling us that they have this technology, and it almost made sense that at some point they would want to show it off. But if this was just made by somebody, crackpotting them, which apparently it was, and I'll accept that, not a problem. But you have to wonder exactly what would their motivations be for just doing that.
Yeah, Bob, that's the question we have about so many things. But if you also look, when the rocket goes up, there's no smoke trail between the rocket and the smoke on the ground. So to me, this looks like one of those NASA smoke coming out of the ground, fake launches. Who knows if it's even something helium is launched, or if it is complete, projection of something. So, it just, looking at the people filming, they're not looking at what we were looking at. And is it just some hacker doing it, or is this actually, the fake space agencies like, hey, let's put this out. This will go viral. It'll look like an independent video. They do all sorts of stuff to get us, spinning our wheels and freaking out. The artificial sun patents, I'm not doubting that. I mean, they're doing something crazy with it, but this might just be getting people to talk about it. That's my feeling.
Yeah, and in fact, they use name as, for example, one of the newest articles or news. Sorry for the redundant words, but it said if you search, for example, China creates an artificial moon and can defeat gravity. If you put that on Google, it's going to, came across with thousands of articles. And when you read it, the moon that China creates, the artificial moon, is just a moon of 30 centimeters in the lab. It is something ridiculous. And so they use all these type of marketing techniques, of course, in the secondary effects to promote the heliocentric model or to produce some fear or to, whatever. No, China now is going to have a super powerful source of energy, so we need to rise up the taxes.
And on top of that, there was an article recently about China with their hypersonic arrow missile or something. I forget exactly what it was called.
Yes,
I'm sure you guys saw it. Yeah, and it goes, ridiculous speeds. So they're getting everybody worried about these crazy weapons that can be shot around the globe, and whatever event that they may be planning, they're just planting so many seeds in people's heads that they'll believe anything or won't be able to figure out anything.
It's the new boogeyman. China is the old Russian style boogeyman. Now it's China. Simply as that.
Hey David, were you watching the part where Jeran was trying to show the snow on the mountain, and then they went around and
yeah, that was the same video, but Jeran discovered something else in the video besides the obviously fisheye lens that they're using for whatever reason, and the switch at the beginning to the mountain not having snow and the mountain having snow. But when the sun comes around 24 hours later, it should be at the same altitude as it was in the beginning, and it's not. It's completely off. It's just completely off. So I didn't catch that the first time.
But Dave, if the sun, if there was snow on the mountain and there wasn't, then the reason that the sun's off is because it's a completely different time of year.
Exactly.
Well, no, it's also, I don't even know why they did it. When the guy's talking about it at the beginning, he steps off camera, and then they use a mountain that's covered with snow on a couple seconds later. So maybe they filmed the next day or hours later. I don't know.
It would have probably been months later if the
sun... I mean, it could be it could be completely different.
Well, how would they get
this? Are you saying that maybe they spliced in 2 parts of the year and we just missed the splice?
Well, the sun to be in different locations would happen if you were talking about, say, 3 months different, right?
Yeah.
So it looks like the part where he comes out and talks is a 3-month different time than the end. And then however they film the going around, it obviously the clouds are the same at the beginning and the end. That's a problem. And and the other thing, I mean, if they had an artificial sun, which I think they have one, we've seen it before, to do something like that around an island or around a small, because think about it, in Antarctica, there's not people everywhere. There's people in very centralized locations. Couldn't you just send that thing in a circle around and film it?
Yeah.
Yeah, not that far away, too. And it looked like it's circling around you.
Wouldn't even.
How would you account for the real sun, though?
Yeah. And the temperatures that they're talking about,
around.
Does anybody believe that? I mean, they might have something that's as bright as the sun, but it's probably like 500 degrees.
Yeah, I don't know.
What I would do is I would do it in the wintertime when it's actually dark. That way they can send their artificial sun in a full 360 and get the full 360 and then just say that it's a summer month.
You gotta stop. You're giving good ideas.
Yeah, no, that's what we always do. That's why they allow us.
The other problem, though, is if they did it when it's dark, I don't think they can get the proper light. It looked like the Blair Witch Project because, our daylight has daylight and sunlight because the sky is backlighting everything. So they would need that artificial sun to create the daylight. And I don't think they could actually do that where they can cast shadows and it would look real at all.
Yeah.
Exactly.
Yeah. I hear
Nobody
you.
can put anything up there.
No, they can't. There's no
They
way
can't.
that they're getting anything above 62 miles. I don't believe it for a second. And if it is, it may be, I'll give it 10 miles a buffer beyond that. But other than that, I don't think so. I don't buy it any further than that.
Well, even if it is real, we know it won't last very long. It's made in China.
Yeah, you got that right.
2-year-old built it, probably.
Alrighty then. All right. Well, on that note, I guess we'll go ahead and call it a show. Wow, it's a long show today, and it ran way over on the main presentation. So, whoops, sorry about that. I guess we'll get back to our normal schedule, like we were supposed to be doing it next week. But whatever. It's our first show back. It was kind of good, and it's kind of good being back together. And I was glad everybody made it today. So let's get last word from anybody that has anything before we get out of here. And Austin, let's go ahead and start with you, sir.
Okay, I guess I got a bit of an announcement. I'll make it on here. So Kai and I are officially getting married in March.
All right.
All right. Congratulations.
Wow, man. Congratulations.
Nice.
Yeah.
Thank you.
Yeah.
Awesome.
Where are
So
you
you're
getting
going
married
to
at?
be married in the church?
No.
You're gonna pay the Vatican? Ah, okay. Okay.
You got connects area?
Catholic Church.
On the beach, man. On the beach, just like immediate family, real small, chill thing near Naples, I think. And then we may just try to have a bunch of flat earthers come kick it a few days later on the spring equinox, but that's about it.
Hey, that sounds good to me. I'd love to come there for that. That'd be awesome.
That'd be cool, man. We would love to have everybody.
Cool.
Congratulations. You guys are well matched. You will be happy.
Thank you.
And pissed on some days, but overall happy.
Yeah.
Make some flat Earth babies.
All right. Duly noted. Will do.
All right. Cool. Okay, Yuri, what you got? Anything, sir?
Well, no, not so much. I recover my main principal channel after YouTube delete the channel. I am
that was
talking
awesome.
about my 90,000 subscriber channel. I recovered like 2 weeks ago, so I'm start updating a few things again, trying to put together in order. But of course now I have 2 main channels, so I'm trying to decide which of those is going to be really the main channel. And also I am very active in my Rokfin channel and English channel too. Right now I'm present, no, not right now, but this week I'm going to present my new webpage in Spanish. It's not in English, but I am, trying to bring more order than chaos into my social networks and things like that. So I was working with that. And a few days ago, my mother came back to Argentina because he came to Europe to visit me and visit some friends. And it was a really hard time for me, from one side, I'm very happy to see my mother because I'm here since May of the last year. So it was a really long period of time for me to don't see my family. But at the same time, having my mother 2 meters from me from 25 following days, it was a little overcharged. But I accomplished the mission. So I'm trying to get back to all the stuff that I left before my mother came.
Awesome. Well, that's cool. I'm glad you got to see her. That's had to feel good for sure. So
yeah.
Excellent. Okay. Well, we'll be. Do you think you're going to be coming through and staying anywhere in the United States when you're on your way back to Argentina?
Well, we was talking about getting back to United States with Linda because for me at least, like I mentioned before, I really love to visit you, Jeran, David. I think that I have some places where to go and sleep a few days.
Yes, you do.
And my question was about the vaccine passport or things like that, if they are asking for that or not to...
Not yet.
How you say it? Not yet.
Not
well,
yet.
that's...
And like I said, it seems to be falling off support for that in many ways. But yeah.
I
So
hate
we'll see
to
what
be the one
happens.
that says this. I really hate to be the one that says this, Bob. They don't have it on our international or on our local flights, but I believe it is required on the internationals.
I
Really?
think too.
Yeah,
Ooh.
I really don't want to say that, but I'm almost
test to get
positive.
in the United States.
Right.
Just
Test to
a
get back.
negative test.
Okay.
Well,
Thank you, David.
It's the same thing here, but a few countries starts to asking for mandatory vaccine passport. Brazil, for example, Ecuador. Here in France, also they are asking for, or at least in the first, when you go into the airline desk. And you present all the things to check in, because that happened because when we arrive from Spain to Basel airport, you can choose to go out from the airport into the French side or to the Swiss side. So when they ask you in the airline desk in Spain, in this case, they say if you are going to go out to the French side, you need to present the vaccine passport. It's not enough to present a PCR test or antigens test, or So for me, it was a little odd because I didn't see any news about a mandatory vaccine passport in France, and I believe that is the only European country that are using that mandatory passport. I know for the fact that in Brazil, because my brother cannot enter into Brazil on December, they are asking for mandatory vaccination passport. So like we talking offline before the show start, there is countries like England that's supposedly going to end everything about face mask and mandatory passport and blah blah blah, and other countries that they are start doing it. So it's a really confused situation.
Seems like a setup. It seems like what's going to happen is the UK is going to have a breakout, and they're going to say it's because they took the restrictions off. So that's coming.
Yeah. But if just for assume, but if in United States they only ask for PCR test, that will be enough to at least start planning our trip. Yeah.
You need to have 3 vaccinations and the booster to stay at my house, though. You and Linda.
I have it.
Okay,
I have a digital paper here.
Okay, good. I want to see.
You guys, travel state governor Karen put it into our chat. Starting on November 8th, foreign national air travels to the United States will be required to be fully vaccinated and to provide proof of vaccination. I don't know if it's something. They're saying all non-immigrant, all non-U.S. air citizens are required to be fully vaccinated and to provide. So it is a new thing that probably there are court cases going against it right now. I don't know where the court cases are on it. But I would, unfortunately, it needs to be addressed and it needs to be fought. It needs to be fought for, and it needs to be fought for now.
Yeah, it does. Well,
I made a post in my Telegram group today, or I forwarded it from somebody else. But if you ask Google whether or not we can, now I want to find exactly the words of it, whether or not we can go up against the government, then Google responds with, yes, in fact, you have a duty to when you're having your rights taken away. And Google flat out tells you, what more do you need to see?
Truth, yeah.
Yeah, the Constitution tells us we have a duty to fight against tyranny. And everyone's just sitting around and letting.
You can just say, "Hey, Google told me to."
Yeah.
Hey.
Right.
Google said.
While I'm talking, can I chat in on something? Can I add something in that we glossed over a little bit when we had the beautiful, beautiful watch up? If people look at that watch again, or actually you can bring up Dave's app, you'll find that if you don't have the $475,000 or the $575,000 lying around your house for that beautiful watch, or even the $400 for the replica, for $999 you can get the What is it, Dave?
It's only $2.99, and it's the Flat Earth.
$2.99.
Thank you, Cami.
Well,
everybody
okay.
knows the name of the app. The Flat Earth.
They know the name of the
It's
app. but
nothing like
no.
that watch, though. I want that watch. I don't want the
The
original.
Watch Originals has the inner gears and that, but all of the information, David has got it exactly right in front of you on how everything works. And kind of, if you look at David's app, you'll notice he also has Greenland right in the middle of it. It's it's a very good how it works in reality, and I thank Dave every day for it. So move it on.
Thank you, Cami.
It's an awesome app.
Thank you, David.
Hey, let me just chime in here on the show. Bob, I want to say that's an excellent show you did today. It was very informative. And I hate when Globers say, you flat earthers, you'll never change your mind. Well, every flat earther, almost without exception, has changed their mind. We were all Globers. And I even remember a time, Bob, where Jeran didn't believe in the downward attraction force. You remember that, Jeran?
I do.
And Jeran changed his mind based on new information. So I think today's presentation was a lot of what we've been shown before, but I think you put it together in such a way that I think a lot of people can now see it.
I'm even further along after today's show.
Today's show I saw some new things that I didn't see before. I'm hoping that somebody takes that and clips it out and makes a short video for it, because that's a good one.
Yeah. Or actually, I should just, what I was thinking about doing, Dave, because it is such an important thing, is I was going to make a scripted video with all my ducks in a row and just go bap, 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 bap. I think that's the better way to do it.
Keep it under 5 minutes.
Yeah. Well, I don't know if I can do that, but I can do it in 10 or 15, I think.
10 or 15
have a good thumbnail and really climactic, dramatic, epic music in the background.
Yes, dramatic music and a good thumbnail. Very important.
All right, I'll do that. Perfect.
I have that quote real quick. It just says, the Declaration of Independence says we have the right to overthrow the government. The Declaration of Independence says that we not only have the right, but we also have the duty to alter or abolish government that does not secure our unalienable rights, including life, liberty, and the pursuit of happiness. So if what's gone on has interjected in your ability to pursue happiness, we have a duty, according to the Constitution, to fight against the tyranny and actually overthrow said government, despite whether or not they put it on the news and call it an insurrection or whatever they want to do. Doesn't matter. Otherwise, your children, your grandchildren are going to be basically slaves. So if you want to get that post, because it's kind of going around, everybody's trying to send it just to show it to people, you can go to t.me/Jeranism links, and it's the most recent post.
Awesome. All right, cool. All right. So let's move along to I didn't do you, Zach, did I yet? I didn't think so I did.
No, not yet.
Okay.
Yeah, I'm excited. Yeah. February 5th. If you'd like to measure the moon, we're doing the moon. It's going to be happening the midnight for that day will be like mid-afternoon. I think my time's like 4 or 5 o'clock in the afternoon. But yeah, we're just going to take a picture 3 hours before that time, every half hour, and then every half hour after that, and for 3 hours after, and then just measure the amount of rotation we get. And hopefully we're going to see a dramatic difference, and I'm going to be jumping up and down screaming like I haven't in a while. I love when we discover something new like that. And yeah, it's neat when you do it yourself and you see it right in front of you. It's been a minute since I've done a cool test like that. So yeah, I'm excited.
I have a question.
February 5th.
I have a question.
What's your question?
Zach, how are you going to photograph the moon 3 hours before 5 o'clock in the afternoon?
I was looking at the moon this morning at 10 o'clock. You can see it out there during the day.
Yeah, you can. Yeah. Okay. Getting the good. Okay. That was stupid. I just had a blonde. I'm kind of thinking where we are in the mountains, or like in our thingy. We can go in the front. We can go in the front yard. I can get out of the backyard and go to the front yard.
Okay, cool. All right. All right. And David, do you have anything you want to drop before we get out of here?
No, I think that's it. Great show. And that's all about all I got to say about that. I'm actually going to go visit Santos Bonacci this this week and do a couple shows from the Syncretism Society. So
Cool.
keep an eye out for those. Yeah.
Yeah, that'd be awesome. Very good. Tell them I said hi.
I will do.
All right. Okay. And I just wanted to thank everybody for the super chats that we got. Got quite a few of them, which is awesome. And let me just read through them really quick. This won't take too long. That Flat Fellows is a great show. Big props to Zack. Glad y'all are back. Brain gravy overload. Thank you, Mr. Flat Fellow. Bex says, woohoo. Thank you, Bex. That Flat Fellow says, glad y'all are back. Looking forward to more great content. And THC Truthers Hour of Comedy, just don't comment, just sends a super chat. Thank you so much for that. Nathan Commercial Sound and Video sent a nice super chat. Thank you much for that. And then on the Rokfin side, looks like we got oh boy, we got all kinds of stuff in the Rokfin side. Let me just go down that real quick. So let me stop the auto scroll. I can't stand that. Okay, Any Word says looking forward to the show. Amos says cheers to all. Shuckle Grabberberg says welcome back. You guys are sorely missed. I know, we're glad to be back. Julie Bennett says so glad you're back. Thank you, Julie. We're glad to be back. Tom O says so glad you're back. Robert Zafaris, Globebusters received a tip. Thank you much, Robert. Rose 777 sent his super chat. Thank you so much for that. And also Paul Lloyd. So that's pretty much for up to the super chats. And that brings us around to Jeran for the last but not least comment before we exit. You got coming up this week, Jeran?
Just coming back to it. So appreciate everybody's patience. Computer's back up, so things are looking good, and we're ready to go. So excited about getting going again.
Cool, outstanding. All right, guys. Well, we will see you. We will see you next week, and we'll be dividing up the shows again like we were last season. And I'll be breaking these down. So we will see you then. And until then, be good to each other. Don't lie to each other. Open your mind, because there's truth inside. Peace out, everybody.
Peace.
Peace.